ICT field. As we all aware, the impact of COVID-19 is felt in every aspect, and there has been a shift in the standard of living. It has strengthened the drive and encouraged intensified collaboration between governments, companies, and non-profit organizations. And it also highlighted the requirement for communities to drag together and handle the risk. In just few months' time, the COVID-19 crisis has brought about years of change in the way companies in all sectors and regions to do business. According to the new McKinsey Global Survey of Executive, their companies have accelerated the digitations of their customers and supply chain interaction and of their internal operation by 3 to 4 years. And the share of digital or digitally enabled products in their portfolio has accelerated by a shocking 7 years. The notion of tipping point for the technology adoption or digital disruption is new, but the survey's data suggests that COVID-19 crisis is a tipping point of a historic proportion, and that more changes will be required as the economic and human situation evolve. In such, so I believe that the theme of this conference, IT opportunities and creativities for digital innovations and communication within the global pandemic, is very relevant to these rapid changes and is very important in highlighting the innovation to accelerate the shift to digital and fundamentally shake up the living landscape. Distinguished guests, keynote speakers, ladies and gentlemen. IEEE Indonesia as a regional organizational unit of IEEE was founded in 1988, and over the past 33 years, IEEE Indonesia has contributed significantly to various activities to encourage science and technology for humanity in Indonesia. Together with volunteers, members, and all stakeholders, IEEE has produced various activities by supporting more than 20,000 IEEE content publications and more than 260 IEEE journal publications by Indonesian authors since 1988. However, we need to encourage the increase in the number of publications accompanied by increased citation by conducting research, collaboration, and internationalization higher education activities. IEEE Indonesia has also sponsored and supported more than 60 high-quality conferences every year, including this conference. And compared with the previous year, in 2021, the conference supported by IEEE increased by 49%. The high-qualified conference papers within the scope of IEEE are published in the IEEE Explore Digital Library indexed by Scopus, Web of Science, and any major databases, with more than 5 million and more than 5 million publications and more than 12 million downloads every month. As we all know, IEEE is always maintain high quality publication as part of our intellectual culture. IEEE Indonesia also holds more than 40 professional, technical, non-technical, and administrative activities for all its members. Currently, we have more than 2,400 members and 60 senior members consisting of professional, industry, academia, and government researchers. IEEE Indonesia also supported 26 technical society chapters, 30 university student branches, including Dian Nuswantoro University Student Branch, and 9 IEEE Student Branches chapter. This chapter has become forum for members for various technical and social activities and provides student members great experience. On July 27, 2021, IEEE Indonesia has established cooperation agreement with Directorate General of Higher Education, Research and Technology to synchronize and support IEEE activities in the Indonesian Ministry of Education, Culture, Research and Technology program, including taking part in the Campus Merdeka and Merdeka Belajar or Independent Campus Freedom to Learn. These historical collaborations have strengthened the development of Indonesian higher education, especially the 8 leading indicators of higher education in Indonesia. IEEE Indonesia also is exploring cooperation with Indonesian industries or in various activities and actively involved in providing input in the direct related government regulation. Ladies and gentlemen, on this occasion, I would like to express my gratitude to all of the committee of Isemantic 2021 who have worked very hard in preparing for this high qualified IEEE seminars. I am very aware that putting together the international conference of this size is not an easy task. Therefore, I sincerely hope for your cooperation and active participation in all of this conference program. I hope all of you will have an enjoyable and valuable experience during this conference event. So please stay active, stay healthy. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Dr. Ingwah Yudi Hasbi, SSE MCOM. Honorable ladies and gentlemen, the next agenda is IEEE Epsilon from IEEE Power and Energy Society from Professor Insinyur Arif Nur Afandi, PhD. The floor is yours.
MC, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector of Dinus and all committee of the Isemantic 2021, also all participants in this conference. Firstly, I want to deliver my gratitude to all the keynote speakers for bringing the success this conference in 2020, Professor Saifur Rahman, Professor Kamanto, also Professor Heru Agus, and Professor Sajjad Nashir. I believe this conference will be bring the future opportunities to the competition of the industry and more opening our knowledge for preparing our future technology and how to apply it in industry also in our human living. In this forum, I want to encourage everyone to join the BES chapter in Indonesia. This chapter was started in January 2015. Now become one of the youth chapter in IEEE Indonesia. So please join and being our community and our team to bring our activity in technology, also knowledge sharing based on the energy and power or related field to develop our activity. Finally, I wish this conference will be one of the flagship conference in our country, also around the world. So please stay tuned in this until the conference of the Isemantic 2020 become finished for all the presenter on parallel session. Thank you. Wassalamualaikum warahmatullahi
wabarakatuh. Thank you, Professor Insinyur Arif Nur Afandi, PhD. Honorable guests, ladies and gentlemen, the next speech is a welcome remark from Rector Dinus University,
Our God,
Professor
the one
Dr. Insinyur
and the
Edi
Almighty,
Sasongko,
for all the blessing and good thing in our life so far, so that we can meet today in this 2021 Isemantic at Universitas Dinus Semarang, Indonesia. Dear all respected
I would
speakers,
like to wish
in
you
this
all
very
a very
important
good morning.
occasion, I would
The first
also
thing to say,
like to mention
we would like
the
to
three
submit our
outstanding
high
keynote
gratitude
speakers today.
to Allah, our
Professor
God,
Saifur
the
Rahman
one
from
and the
Virginia
Almighty,
Polytechnic
for
Institute
all the
and
blessing
State
and
University,
good thing
Virginia
in our life
Technology.
so far, so that
Dr.
we can
Muhammad
meet today
Sasad
in
Nasir,
this 2021
an associate
Isemantic
professor
at
from
Universitas
Dinus
Suwantoro,
Institute of
Semarang,
Technology,
Indonesia.
China.
Dear all
Professor
respected
Insinyur
speakers,
Kamayanto,
in this very
Toro,
important
Magister
occasion,
Engineer,
I would
PhD,
also
a
like to
Professor of
mention
Wireless
the three
Communication and
outstanding keynote
Radio
speakers today.
Propagation from Institute Technology
Professor
School
Saifur
November,
Rahman
Surabaya.
from Virginia Polytechnic Institute
Heru Agus
and State
Santoso,
University, Virginia
a senior
Technology.
lecturer from
Dr.
Awatila
Muhammad
Universitas
Nasir,
Dinus Semarang.
an associate professor
Dear
from
all distinguished
Institute of
Honorable
Technology,
research
China.
guests and all the
Professor
audience,
Insinyur Kamayanto,
we thank you very much for coming
Magister
today
Engineer,
and being here
PhD,
in the great
a
seminar
Professor
with
of
us
Wireless
today.
Communication and
We
Radio
grateful
Wave
and proudly
Propagation
welcome
from
you all
Institute
on this
Technology 10 November,
international
Surabaya.
summit on application for technology
Heru
of
Agus Santoso,
information
PhD,
and communication of
a
the
senior lecturer
2021
from
Isemantic
Awatila
at Universitas Dinus Semarang, Indonesia. I would
Dear
also
all
like to wish all of you,
Honorable
all your
research
family, and all your
guests
colleagues,
and all the
the great health and safety during this unlucky pandemic circumstances. May God bless you all. Amen. I would also like to thank all the doctors, nurses, and all medical professionals who have given their best health service in the front line of this long pandemic crisis. May God also bless you all. Amen. Alhamdulillah Rabbil Alamin. We all thanks Allah, God the Almighty, for the blessing and great help and the safety granted to us all. In this pandemic situation, we still encourage ourselves to maintain the passion for conducting great research, which are in the line with the topic of today's seminar. IT opportunity and creativities for digital innovation and communication within the global pandemic. The precision as well as the development of technology for information and the communication are the main key for all researchers to answer all the challenges in the future. We also encourage all of you to join the seminar and to contribute your active participation. We all great discussion and expectation. We hope that this conference can be good platform for academic exchange of information and knowledge on the development and innovation of information technology, and also good platform for new collaboration of scholars, academicians, scientists, and other practitioners. We appreciate all the steering committee of the seminar, and we also thank the conference management. Our appreciation also goes to all the reviewers and other, as well as co-author for their fruitful contribution for this great 2021 Isemantic to happen today. We also mention our cooperation agency, IEEE of Indonesia section, IEEE of Universitas Dinus Press, and IEEE of Power and Energy Society. We thank you for all your collaborative support, your participation, conferencing process, and the sponsorship. The last to say, we all great learners. We all want to give the best of research finding to work in this 2021 Isemantic. The word contribution is important for us to comprehend because our contribution will lead to positive change to our life as well as the life in the world. Therefore, research should enhance the innovation and their function to applicable in the daily life of our society. Finally, a research plan of concept and experience to result in high quality innovation in its unique finding. A research can become a good practice with a great benefit for all society. A research is also gradual transfer of goodness with its good effect and impact to people in the general public. We thank you very much again. Wassalamualaikum warahmatullahi wabarakatuh. Universitas Dinus Semarang, Indonesia. Rektor Dinus.
Thank you, Professor Dr. Insinyur Dinus MCom, for a warm welcome and hospitality toward our committee and participants. Honorable ladies and gentlemen, now let's enjoy video presentation of Isemantic journey through the year.
Information technology, or IT, plays an important role in supporting human life and civilization. It does not only make our life easier, but also preserve our culture. Dinus University Semarang initiate Isemantic as a place to develop information technology and opens the discourse of critical thinking scope among the academics and the Indonesian societies. International Seminar on Application for Technology of Information and Communication, or widely known as Isemantic, is an international seminar held annually and covering multi-field studies, including engineering, economy and economics, health and culture. Even more, researchers, lecturers, students, and industrial societies are welcome to join this seminar. Isemantic through the years has been accepted by the academic world enthusiastically. Many keynote speakers from Indonesia's top universities and international top universities have come and cooperated in this event. Hundreds of papers have been published along with interestingly different and challenging themes each year. In 2016, highlighting the importance of science and technology in assisting society towards a better life and future, Isemantic presented Science and Technology for a Better Future as the theme. The keynote speakers from Kementerian Riset Teknologi dan Pendidikan Tinggi or Ministry of Research and Technology, California Polytechnic State University, School of Electrical Engineering and Informatics of ITB, and Nanjing Chichen Medical Technology of Nanjing, China, joining and sharing their respective knowledge. In 2017, in order to achieve a better human life, our society needed empowerment to bring out the best of human beings. Thus, the theme Empowering Technology for a Better Human Life was chosen as the core of the seminar. The keynote speakers from Kementerian Kelautan dan Perikanan Republik Indonesia or Ministry of Marine Affairs and Fisheries Republic of Indonesia and Tokyo University of Technology shared their knowledge on how technology empower Indonesia's marine sovereignty and how technology has changed the face and future of animation. In 2018, Creative Technology for Human Life was the main theme of the year, along with the needs of health literacy acceleration in our society. The keynote speakers from University of Technology Sydney, LIPI or Indonesian Institutes of Sciences, and Taipei Medical University talk about the importance of life quality improvement, environmental sustainability, and national culture preservation. In 2019, the birth of 4.0 industrial era had changed the way our society considered the economics, technology, and communication. The keynote speakers from Kementerian Riset Teknologi dan Pendidikan Tinggi Republik Indonesia or Ministry of Research and Technology Republic of Indonesia, Curtin University Australia, Kumamoto University Japan, and Mitsubishi Electric Corporation Japan. Renewable energy resources and digitalization of conventional industry were two main discussions in the seminar. Isemantic through the years, both giving contribution to the academic fields and opening the accessibility of Semarang tourism to the world. Grand Mayeropocho Central Java Culture Park and Lawang Sewu Historical Museum are the two most famous Semarang tourism sites. The Isemantic participants enjoyed little pieces of Semarang's hospitality and culture. The night before they departed, a warm dinner was held to close the whole event of Isemantic as a remembrance of the friendship among participants.
Assalamualaikum warahmatullahi
Amidst the global pandemic of COVID-19, Dinus University made a great virtual steps on the execution of the 2020 Isemantic. The 2020 Isemantic, with the theme IT Challenges for Sustainability, Scalability, and Security in the Age of Digital Disruption, was held through online conference platform. The keynote speakers from Dinus University, University of Auckland, and Tokyo University of Technology Japan shared the importance to stay adaptive through the digital disruption era. Finally, today, information technology opportunities and creativities for digital innovation and communication within global pandemic is the theme of the 2021 Isemantic. With the IEEE publication and Scopus indexation, hundreds of manuscripts are ready to be presented and reviewed through the online conference platform of the 2021 Isemantic. The keynote speakers from Virginia Polytechnic Institute and State University, Institut Teknologi 10 November, Dian Nuswantoro University, and Huayin Institute of Technology of China will present interesting, challenging, and mind-sparking discussion to us.
Honorable ladies and gentlemen, the next session follow is a photo session. We have certain conduct to follow which are: first photo session, we would like to invite all keynote speakers on Zoom camera. Don't forget to give the best smile, please. Okay, the committee will be take the picture. Okay, I think it's enough. And then the next photo session, we would like to invite all keynote speakers and Mr. Sandy as the chair of the technical program committee on Zoom camera. Okay, also give the best smiley. Thank you very much. Thank you for the photo session, and let us prepare ourselves for the next session. Ladies and gentlemen, the next agenda is seminar and discussion with our today's keynote speakers. This session will be guided by Professor Dr. Jumanto from Dinus University and Titin Suhartini, Eskom Master of Engineering from Dinus University. But before we start, let me read a brief biography of the moderators. Jumanto, or read Jumanto, completed his doctorate degree, a PhD in linguistics from Universitas Indonesia in 2006. He is now a professor of linguistics, especially of linguistic pragmatic and of English language teaching (ELT) for graduate and postgraduate studies since 1992. Head of English Department, Faculty of Humanities. His most recent office is a member of CUA, Center of Excellence, Universitas Dianuswantoro Semarang, Indonesia. And next, Titin S. Sukamto, Eskom Master of Engineering, lecturer at Information System Department, Dianuswantoro University. She achieved her bachelor degree in Information System and master degree in Electrical Engineering and Information Technology. To the today's moderators, the floor is yours.
Thank you very much, Mr. MC, Mr. Distinguished Heri Pamungkas. Well, Assalamualaikum warahmatullahi wabarakatuh. May God bless us all. Ladies and gentlemen, today's most distinguished ladies and gentlemen, first of all, we are wishing you good morning, very good morning, and also very good evening on the other side of the world. All the Dinusians, all the researchers at Dianuswantoro University, as well as all the researchers all over the world, particularly those who are present and very attentive to this 2021 Isemantic International Seminar on Application for Technology of Information and Communication of this very year 2021, or we call it the 2021 Isemantic. Ms. Titin.
Welcome. Welcome. Welcome to this webinar 2021 Isemantic. This is the sixth Isemantic and the second webinar Isemantic. Prof. Choi?
Well, distinguished audience, we all probably live by information technology today, IT. Within this 2021 Isemantic, we are raising the topics about opportunity and creativity of course, information technology. The theme of the 2021 Isemantic today, as you have noted, is IT opportunities and creativities for digital innovation and communication within the global pandemic. Well, ladies and gentlemen, opportunity refers to a situation or circumstances that something can be done. This something is of information technology, having to do with probably break, chance, occasion, opening, room, and shot. Meanwhile, creativity refers to the ability to create, having to do with probably cleverness, creativeness, imagination, imaginativeness, ingeniousness, ingenuity, innovativeness, invention, inventiveness, originality. Ms. Titin.
Well, ladies and gentlemen, to elaborate the opportunity and creativity of IT today, in this very great occasion, we would like to present to you the outstanding of keynote speakers. Professor Saifur Rahman from Virginia Polytechnic Institute and State University, Virginia Tech, Dr. Muhammad Shahzad Nazir from Huayin Institute of Technology, China, Profesor Gamantio Hendrantoro from Institut Teknologi 10 November Surabaya, Indonesia, and Dr. Heru Agus Santoso from our beloved Universitas Dinus. Prof. Choi?
Well, ladies and gentlemen, the presenters today will speak to you one after the other, so you all will feel convenient to focus on their respective topics and discuss with them one by one to the best of your interest as well as of your comprehension. Ms. Titin.
Okay, let's start with presenter one, shall we? For sure.
Well. Now we are coming to the show. Okay, we're coming for the first show. We are coming to Professor Saifur Rahman. I'd like to greet the gentleman. Yeah, Professor Saifur Rahman, are you here? Are you with us today?
Assalamualaikum, I'm here.
Waalaikumsalam warahmatullahi wabarakatuh. Well, this expert is, we've been looking forward to your being here, Professor. Well, we have noted your performances throughout the world. Well, thank you very much for being here. We'd like to say something before your presentation. Professor Saifur Rahman, an expert in alternate energy from Virginia Polytechnic Institute and State University, Virginia Tech. Professor Rahman today will be talking about Internet of Things, IoT, sensor integration for digital control of the building environment in a smart grid ecosystem. Well, this is very great topic. But before that, hold on a minute. Let's listen to some introduction by Ms. Titin to our Professor Saifur Rahman here. Ms. Titin, please.
Excuse me, sir. I would like to read your brief bio. Okay, Professor Saifur Rahman, PhD from Virginia Polytechnic Institute and State University, Virginia Tech. Currently, the candidate for IEEE President-elect. Joseph Dwaring, Professor and Director, Virginia Tech Advanced Research Institute, Virginia. Received his bachelor degree in Electrical Engineering, Bangladesh University of Engineering and Technology. Master of Electrical Engineering from State University of New York, and PhD degree from Electrical Engineering, Virginia Tech. In 2000, he had awarded the IEEE Millennium Medal for outstanding achievements and contributions to IEEE. In 2011, he received the IEEE USA Professional Achievement Award. In 2012, received the Meritorious Service Award, the highest award bestowed by Power Energy Society. 2013, awarded Outstanding Power Engineering Educator from PAS. 2014 honorary of the IEEE Technical Activities Board Hall of Honor. He has helped IEEE Indonesian section a lot, and his research interests are alternate energy, critical infrastructure assessment and modeling, uncertainty evaluation, environmental impact. Wow, such a great biography, sir.
What a wow, what an achievement, Professor Rahman. Well, and we are happy to have you here. This is the world expert coming to virtual University of Dinus. Well, we are very proud as well as very happy for your being here among us. Okay, without much further ado, we're coming to the presentation, the first presentation of Isemantic 2021 with Professor Rahman. Professor Rahman, you can start now with, please make it convenient in 40 minutes. Okay, it will start from now. Thank you very much.
1 second. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. You know, you have given a long introduction for me. Or something.
Not very long.
Very long. What is missed is I've been to Indonesia many times. Saya bicara bahasa Indonesia sedikit-sedikit.
Oh, wow.
I've given lectures at Trisakti University in Jakarta, UI in Jakarta, ITB in Bandung. I spent 3 months in Palembang lecturing at Unsri. I've been to Semarang. Pak Anggoro took me there 3 years ago. I have not been to Universitas Dian Nuswantara yet. Inshallah, I'll be there soon. So
sorry, Professor Saiful, you were already in Udinus, I think 4 or 5 years ago.
That's right. That's one lecture. You're right.
Yeah, one
exactly.
lecture.
So I come from Bangladesh originally. So I like Indonesian food. I like Indonesian people. I like Indonesian culture. The good thing is, Bahasa Indonesia is easy language to learn. I learned in 2 months. I could speak fluently, not in English. So I am a familiar person in Indonesia. I wish this meeting was face-to-face. But anyway, inshallah, we'll do this. So, back to the topic of my speech today, we focus on smart buildings, smart grid, and IoT sensors. So let's move on with that knowledge going forward. We have developed what is called open architecture platform for building energy efficiency. That's our research. If you want to know more, there is a website, the yellow box on the right-hand side, www.demoss.org. If you go there, you'll find my algorithm, technical papers, test bed, all that is there if you want to know more. So what we have done, we have developed a building energy management open architecture software solution that can be used to sense and control any IoT device for commercial buildings. Our application has been so far in the area of heating, ventilation, air conditioning, lighting load, plug loads, and the result has been to give you better air quality in the building and provides energy savings. Why is air quality important in a building, especially with COVID-19? You have to know in the building ventilation system ventilation has virus. We can do that fairly easily with this platform. We'll talk about that more later on. This is my lab to show you, as many of your professors will teach labs, how we built it. This is a floor in my building on the left-hand side. We put in the lab different kinds of thermostats on the left-hand side. There are 1 to 5 thermostats here, controlling the volume of air, VAV controller, rooftop unit, smart light bulb, light switch, lighting load controller, dim ballast, smart plug, different kinds, Wi-Fi smart plug, Zigbee smart plug, backnet controller, occupancy sensor, light sensor, and power meter. All of that in the lab. So the point I'm trying to make is we have built a platform which can talk to any of these devices and control your light intensity, control your temperature, control ventilation, all of that. In the beginning, we used something called Raspberry Pi, very small microcomputer. The Raspberry Pi is sitting inside this gray color plastic box. It is collecting information, Wi-Fi, all these devices. Some devices on the upper right-hand side are not Wi-Fi. These are analog, backnet Modbus. We have put an IP converter. It receives analog signal and provides Wi-Fi signal output. That's how we do this. All that is done. This is one building. The point is, we have to be very careful in terms of technology. What does it mean? As some of you know who teach communications, there are many technologies for communication, Ethernet, serial interface, Zigbee, Wi-Fi, many different kinds, right? Also have data exchange protocols, backnet, Modbus, web, Zigbee, smart energy, open area. Our challenge was, we are a university, we don't make hardware. We buy hardware from the market. A vendor for a hardware, thermostat, smart plug, smart switch, use the protocol they feel secure. We developed some translation where we could take any signal on the list of 10 on the left-hand side, convert that to IP or Wi-Fi, and run it. That was our contribution. It worked well so far. So this was one building. Now a campus, like UI campus or your Unidian Nuswantara campus, whereby you have many buildings. We have done this idea now, rather than putting a small microcomputer in a building, most buildings today have internet. So we have cloud account now. In the cloud account, we will host our algorithm. That's BMOS algorithm, hosted there. Each building has an account in the cloud because internet sends signals, receives signals, and work fine. This is how we can guarantee occupant comfort, demand management, energy savings, security surveillance, alarm notifications. All that is going on today. Also, our cloud has connection to power company like PLN, power company. They send signals for load control, we receive it and take action. That's happening in our situation today. Now, in addition to controlling temperature, ventilation, light intensity, we did two other things. Look at this issue here. We have some number. These are data from our experiment. We see typical building cooling and heating situation. By controlling some temperature set point, we can save about 20% energy on an annual basis. For lighting control, by dimming some lights, scheduling light on and off, we save about 25%. That's fine. But important discovery was the second two bullets, improved operations and maintenance. We developed a product called WISE Building, WISE-BLDG, that enables operators to monitor the power consumption on any device. Example, you have an air conditioner on the building roof. We monitor the air conditioner motor power draw, current voltage in real time. Every minute we are measuring. If the air conditioner compressor is running tight because of a dirt or some bearing problem, it draws more current. As soon as it begins to draw more than normal current, we send a signal to the building engineer, come look at it. And they can fix things before it breaks down. That's operation maintenance. Other thing is occupant satisfaction. We monitor in the building many things. One is carbon dioxide, We can also monitor PM2.5, SARS-CoV-2 virus concentration. And based on that, we some action to keep the building more healthy. Now, some examples. We have deployed our solution in many buildings in Virginia, Maryland, in the US. Just pick one building from our list. This is an old building. Some people tell me that to make a smart building, you must build it smart from the beginning. That's not possible. In the US, 90% of buildings are more than 15 years old. They're not smart. What do you do with them? Well, we have a solution. We provide equipment, sensors, controllers in the building, which can be wireless. So, this building in front of us is 74 years old. Old building, 74 years old. This building was not built smart. We have put hardware, we put sensors, and show an example in a second. So building is smart. Example, look at this building, one classroom. That building. This classroom has no windows. People come into class to sit and listen to the lecture. What we did to monitor the health of air quality in that classroom, we put a sensor which measures carbon dioxide, noise, temperature, and relative humidity. One device, Wi-Fi. That's in the room, in the ceiling, put it there. We also have this box called BMOS core. That's a Raspberry Pi in that classroom, monitoring all this information, carbon dioxide, noise, temperature, and humidity. Below that BMOS core box, I have a smart plug. Why is it important? Before we put the smart plug, the classroom you can see has a computer, it has an LCD projector, it has a printer. Those are turned on, left on, nobody turns them on. Smart plug, if you hook your printer to the smart plug, go home at night, 9, 10 p.m., 10 p.m., it automatically turned off because you program it to turn off at 10 p.m. every day. That's saving energy. Go across the room on the left-hand side, motion sensor. If the classroom has nobody in there, why cool it so much? Why keep the light on 100%? We don't, because of the knowledge we have that we can detect people in the room or not. Above that is a smart Wi-Fi thermostat. Why Wi-Fi thermostat? We can monitor its operation remote. And on the left-hand side, the top, we're also monitoring the air conditioning unit on the roof, which is serving this floor. So we have to know by doing lighting control, air conditioning control, occupancy-based lighting availability, are you saving anything? We measure that in real time. Good. Now, let's see some data. This is a screenshot from iPad, which is running this system. We have indoor temperature, humidity, many things in the back covered up, noise, CO2, all that. Look at the blue box on the lower right-hand side. That shows the CO2 concentration in this classroom over 24 hours. Early in the day, 9 o'clock, is about 500, which is close to ambient average. Slowly goes up to about 600 by 3 o'clock, 4 o'clock. Class starts at 6:30. By 7 o'clock, begins to rise. 700, 800, 900, 1000, 1100 CO2 concentration in the building. This is not very healthy. Data shows inside an enclosed space, if your CO2 concentration goes over 700 parts per million, it is not very healthy. What do we do? When we measure this data, we look to the classroom. When the CO2 concentration in this classroom goes over 700, we throw more fresh air, dilute the CO2. Similarly, if I could measure the SARS-CoV-2 virus concentration using a sensor, it's not there yet, I could throw more fresh air. If it is dangerous, I'll give a warning that leave this room. This room is not safe to warn anybody. That's the benefit of digitization. We talk about theme of the conference. You have signals which can help you to maintain a healthy building operation. Good. That was the CO2 part. Now, how is it done? The typical examples of outdoor air intake. Many of you know this probably. Every building, enclosed commercial building, has to have some fresh air all the time. Otherwise, building builds up too much CO2 and other gases. So outdoor air intake is fine. What we can do, we can put IoT sensors in the indoor air supply. See these ducts, these are indoor air supply. If you put sensors inside these ducts, you'd know the concentration of CO2, PM2.5, SARS-CoV-2, and based on that information, we can take some action to make the building more healthy. We can do that from this protocol that we developed. There was CO2. So going back, this is the information on energy and power usage. Same building, the 74-year-old building that you see on the top. We're measuring in that one floor the temperature, which is the green line. Red line is the set point, which is about 23 degrees centigrade. And the blue line, the operation of the air conditioner. For the purpose of energy savings, we said we will not turn the AC on between 1 p.m. and 5 p.m. See what happens. This is the right-hand picture with the yellow numbers on the top and bottom. We said we'll allow the temperature to go from 74, which is 22 or 23, to 77, 25 degrees centigrade, 25 upper level. And we turn the AC off. See what happens. You can see the green lines are slowly going up. It started about 19 degrees, go up to 25 by 5 p.m. AC didn't turn on. It was fine. You can see the results. The gray box on the left, energy usage for 4 hours, 1 to 5 p.m., 2.72 kilowatt hours. Peak load was for that floor 4 kilowatts, 3.9. That's without our control. When we put the control, AC was not turning on, fan was on. Energy usage was half. It was 2.7, became 1.4. Peak load was 3.98, became 0.5. That's a good example of energy savings, peak load savings, and of course, CO2 management. Let's look at a different building, or real buildings in our neighborhood. See, building, they have garage for working on school buses. Upstairs, their office. This office, I went there about lunchtime, nobody around. We have this work area in the middle. There's a skylight, get sunlight coming in. Ceiling lights all on, full capacity, nobody's around. On the upper right-hand side, we have staff area, they went to lunch, nobody's there. Still light on, full capacity. Below that is a conference room, no conference is happening, still lights are on. That's normal. We said, can you turn lights off? They said, no, if you turn lights off, it will get uncomfortable. Can you dim it? They could not. We put a technology to dim the lights. But dimming the lights, by meaning make them less concentrated, two things, lunch hour. Also, when the sunlight comes in, we have a light sensor on the wall right here. That is measuring the total light, the sunlight plus the ceiling light. If sunlight is strong, it will dim the ceiling light automatically. When sunlight goes away, it goes back to full capacity. By doing this control, see the numbers on the bottom of the screen here, you're saving about 33-34% month to month just by dimming and scheduling. That can be done. So now we have talked about smart building. What makes a building smart? You have to have monitoring and control of heating, air conditioning, ventilation, lighting, water supply, sensor network, security camera, fire emergency. All of this is there. Typically what happens in any big building in Jakarta, they have this, but they have 8 different platforms, one for emergency fire, one for camera, one for sensor, one for water supply, one for HVAC. We have developed this wise building platform can take care of all of them in one location. That was smart building. We are going into smart grid slowly. This is, a microgrid. What is a microgrid? It is a collection of buildings, including some supply. In Chicago, Bronzeville microgrid, there are many buildings, homes, math academy, police headquarters, the medical institute, college of optometry, nursing and living center, and military academy. In part of Chicago, the real building, right? Real situation. You know, the rooftop solar, battery storage, and 2 substations serving the network and connected to another microgrid in the city of Chicago as well. That's a typical microgrid. My point is, you can control part of Jakarta and the whole of it together. It's difficult, big city. Take a piece around, let's say, Trisakti University or UI. Do that and see what can be done. As an example, this is going from smart building to microgrid to the big smart grid now. How is the grid changing over time? The top half of my screen is a system before smart grid. Power station, step-up transformer, long distance transmission line, step-down transformer, local distribution line, and your building. It's normal. What is new is the lower half of my screen. I have roof, I have solar panels, battery storage, I have wind turbines, electric vehicles, the green one, all that is there. In addition, I have to have big power station and factories. My point is Indonesia is big in coal today, coal power generation, a lot of coal. We cannot turn the coal plants off in the next 25 years. Maybe 2050, we can get rid of it. That means next 30 years, we have to live with the large thermal power plants, but slowly we add more and more renewable generation and battery. What you see in this picture also, the dotted blue lines, that is not power line, these are communication lines. You must have real-time communication between the rooftop solar, storage battery, electric vehicle, and building load. Make sure every second the load and the supply are matched. That's a challenge for any engineer. So how to do this? We can merge power flow with information flow now. We call it integrated communications. Look at this picture. This is my traditional electric power infrastructure. We know this, right? Power station, step-up transformer, long distance transmission line. Then you go, sorry, I went too fast, 1 second. Then you go to this picture here, where I have added what I call information infrastructure, right? Where I'm adding a telecom network to connect all the buildings and all the substations together so that you'll know in real time how much power is being consumed at every location, what's the voltage, current, frequency, power factor. That's our complete smart grid going forward. So this is my vision for the future. If you talk about smart grid, this is not going to happen overnight, take many years. What will happen step by step? I'll have what is called intelligent, interconnected microgrids. What's a microgrid? You saw Chicago Bronzeville, part of the city, right? Many buildings, 2 substations, solar rooftop, battery storage, all of that. Here, I'm showing 1, 2, 3, 4 microgrids. One in the middle on the top has multiple homes, rooftop solar, has the electric vehicle, and this box is the controlling the devices in the microgrid. The one on the right-hand side, another microgrid has a storage battery in it. Why is it important? A microgrid can survive if it loses the network power. If I cut these 2 lines, network power, on the both sides, I can survive. But I have to manage my load more carefully because I don't have 100% backup. So battery will help. The microgrid in the middle is a bigger microgrid that is involving, for example, buildings on Jalan Sudirman in Jakarta, for example. These big buildings are there. These are connected to a windmill with transformers, power network on the lower right-hand side, transformers, and large factories. That's possible. What I'm saying, it is possible for the bigger microgrid to supply power to the smaller microgrids because it has connectivity to the main power station. At the bottom, another microgrid, it has more battery storage. One solar, not many solar, like the top one. My point is, you'll have many microgrids. One could be DC microgrid. One could be microgrid focusing on solar power only. One microgrid can focus on battery storage. All that is learning. PLN engineers from PLN can look at this option and decide how to design the system going forward. So this is my summary. I call it smart grid ecosystem. Starts with a smart building, the yellow circle in the middle, then goes to microgrid. We show in Chicago example for you. Then distribution system, many microgrids interconnected, give you distribution system. Then many such systems will form the smart grid. So you have a Jakarta distribution system, Palembang distribution system, Bandung distribution system, all connected by PLN in a smart grid environment. So for a smart building, it must have intelligent building automation systems, smart devices, productive users, and grid integration. The grid is kind of stressed out, supply limited, building can dim their lights a little bit. They can change the air conditioning set point to save energy. That's how I think systems should grow in the future. That's it. I'm done. I've given you my email address. If you have any questions, I can answer now. Please write to me. I'll answer. Also, my website has many of my papers if you're interested to follow up. I'm in Facebook, on LinkedIn, Twitter, and YouTube. You find me there as well. Again, somebody mentioned before, we have now the election going on for IEEE. It's ongoing right now. You can vote till October 1st. Indonesia has a very strong, active IEEE section. Many members are there, maybe 1,000 members in Indonesia. So go to the website, www.ieee.org/elections. You see there are 4 candidates, and you can read their bios and decide whom to vote for. Please vote. This is important. We have a role to play in choosing the next IEEE president. With that, let me stop here, and I'll take questions and comments. Terima kasih.
Well, it was a very great presentation, Professor Rahman. Well, so many things come to our mind, our thoughts, and our intriguing minds. Yeah, this is something. Yeah, I hope that the audience is very attentive wherever you are. So we are now coming to the Q&A sessions, but I'm so sorry. We are so sorry. We only opening chats. So please write down your questions in the chat. We will select the most appropriate questions for Professor Rahman to answer. Okay, because Professor Rahman is very generous, we have additional 10 minutes from the 20 minutes planned by the committee. So we have 30 minutes for the QA sessions. Okay, please now open from now. Please type your questions.
Just to let people start thinking about this whole idea. The last slide that I showed, or last second to the last one. People talk about smart grid. Smart grid is not easy to do. It's very expensive. It is very complex. So it will not happen overnight. If you want to build up to a smart grid, you have to step by step. And my theory is you have to build a smaller section, PLN part of Jakarta, for example, and see how benefit you get, how much money it takes. Is it helping the building to be more efficient? All those things have been discussed. So I hope there are many professors here, many universities. You will take this carefully, and I can send you a copy of my slides here, and you can use it any way you like to bring students' interest in asking these questions. I'll give you a very simple example. Smart grid is very expensive, not cheap, very expensive. Starts with smart meter. In Virginia, to deploy a smart meter costs about $200 US, one smart meter. The meter itself costs about $40, $40. Remaining $150 for telecom network you need to collect real-time data. So what can you do in Indonesia, in Semarang, in Jakarta to reduce the telecom expense? Then the cost goes down. That's the research challenge. Nobody has solved that yet. It takes a lot of time and technical know-how. So a lot of opportunity are here for you to get involved in many levels of smart grid, smart distribution systems. Just keep that thought in mind as we go forward. Okay, so let's see some questions now.
Okay, thank you very much, Professor. We still have 20 minutes then. Okay, ladies and gentlemen, please, this is very interesting topic. There are so many things I think very new to us. So this is the expert is ready for responding to your questions, please. Okay, well, waiting for the questions from the audience, Professor, I'd like to say something that the IoT and smart buildings, you said in the presentation, all buildings in the Arlington, for example, also, but they are modified into smart buildings. Are there any obstacles applying the smart building facilities to the old buildings in your experience?
Yes, there are obstacles because of lack of knowledge. For example, when we chose to deploy smart thermostats in that building, they're asking me, well, it's working fine, why change the thermostat? It's working fine when it works. Example, the classroom I showed you is evening class. They come to class about 6:30 p.m., leave at 9:30 p.m. Hot summer day. When they come in, they want to cool the room. They brought the temperature to maybe 15 or 16 degrees centigrade. The thing, make it low, it cool faster, doesn't it work that way? Anyway, they're in the classroom, everything is fine, they leave. Nobody remembers to turn it back on to 21. Still 16, Friday night. All weekend, it's 16. All weekend. It's very cold. Monday morning, staff comes to work, they wear a sweater. It's so cold in the building, summertime. So all weekend, you wasted so much energy, nobody cared. If I have a smart thermostat now, can be programmed. In fact, the director of the building can see from home on Friday night on her smartphone what is the temperature reading of the thermostat. She sees 16, she can change it to 21, 22, 24. That's a cultural thing. That's the barrier. You have to let people know you invest money, it does good things for you. It took us a few months to convince them, but finally we could. That's all of the challenge.
Okay, thank you very much, Professor. Well, we have somebody here ready to ask questions, Mr. Anggoro. Yeah, Mr. Anggoro. Okay, are you ready, sir, Mr. Anggoro, to ask a question?
Yes,
Okay,
I'm ready.
please.
Thank you, Mr. and Mrs. Moderator. Good morning. Good evening, Professor Saifur. I would like to. I have two questions for you. Since Indonesia is a country of, I think, thousands of islands, I'm thinking that maybe microgrid is more suitable for us. I mean, rather than we are trying to build a super grid connecting all the island in Indonesia, or maybe microgrid is more suitable because then each microgrid will consist of its energy sources with suitable for each location. What do you think about this idea, and what do you suggest to make this kind of reality for us? The second question is, as the moderator stated that you are running for IEEE president, can you elaborate what is your plan for IEEE if you are elected as a president? Thank you.
Okay, Pangoro, thank you for those two questions. Yes, I fully agree with you that microgrid with as much local supply as possible is a better solution for Indonesia for two reasons. If you want to do super grid, whole country is a lot of money to be spent, Number one. Number two, it's difficult to maintain for a long time. You got storm, you got cyclones. So I would not recommend that. The reason they do super grid, they have one big or many big power stations pumping power to the whole country. That is not going to work very well because of the safety and security issues. But if you have many islands, small ones, with microgrid, you need some local generation. How would you manage that? You have a lot of wind opportunities, solar opportunities, of course, diesel backup some. So we have to have a very smart thinking, combination of different possibilities. That's cheaper in the long run. So I would recommend look at this very seriously, microgrid options for Indonesia. If the islands are nearby, you can connect them. It's okay, undersea cable. But do not plan to connect whole country 2,000 kilometers out and all the power stations. It's not safe to do that, number one. Number two, if I become IEEE president, what I'll do differently? I'm a person who believes in ground up. I've met all over the world thousands of engineers, thousands of people, and I see one thing they ask me all the time: make IEEE more useful to me, not just reading technical papers. As an engineer, what do I do? So I have built for our society PES. I'm the founder of PES University to provide training materials for engineers from the university website. So answer to your question, Pangoro, is I want to make local sections like Jakarta, people like you, local chapters, have some say in how you want IEEE to provide services in your case. That'll be my operating principle.
Thank you very much, Professor Saiful. Good luck to you.
Thank you.
Thank you very much, Mr. Hanggoro. Well, while waiting for the other questions from the audience, well, Dinus University is very proud of you, Mr. Professor Rahman. So we wish you good luck for the presidency, for the next year.
Good luck,
so,
sir.
Well, yeah, hopefully you are very competent for being in that position. Okay, somebody please. We still have, about 15 minutes. If you are ready to ask question, please type something on the chat, and then we will call you to be in the screen with Professor Rahman. Okay, while waiting for a question from the audience, we also like to say something, Professor Rahman. We are talking about smart buildings. Do you think, what do you think of the people if they are counting on the smart building? Are they becoming less smart or something? Is this fear also happening to our mind experts? If we are creating smart buildings and then the people will be less smart. What do you think? Because we are counting on very much on the facilities.
Typical office worker spends half of their waking hours inside a building, 40, 50 hours a week, waking hours, half of it. What we are saying, we want to make the building more healthy, better air quality, so that in the smart building environment, you like to stay in the building as much as possible because you feel a comfortable working environment. That's my objective. Controlling temperature, ventilation, airflow, humidity, and sometimes lighting control. So what it does, it makes you, the person working in the building, more productive, and you want to spend more time there so that you are not just spending 8 hours a day, you're functioning much better, producing better output. So you go home more relaxed. If you are in a building with a high level of CO2 concentration, you go home tired, lack of energy, don't feel like doing anything after you come back from office. That will change if we can maintain the high air quality in the building. Now, especially with COVID-19, it's very important to have data about the building air quality in terms of virus concentration. That is one way this technology can help. I hope that makes sense to you.
Thank you very much. Well, there is something, yeah. And so by smart buildings application in our facilities, it seems that we are spending less energy and using our more energy for something else, more beneficial for humanity. Something like that, Professor?
Yes. You know, different topic, global warming, decarbonization. That means we'll be using less fuel, using less electricity, and you produce less CO2. That's objective globally. Many countries, US, Europe, said by 2040, 45, they will be making no carbon-based output, nothing, no CO2 from power generation, zero. The problem with that, problem is you cannot keep on using more energy and make everything from solar. It's not possible. So I think to get a better solution, the system we're working today, we use less energy. Like the example I gave you, 20%, 30% less energy used to run the building for lighting and air conditioning. What does it mean? If you use 20% less energy, that means you burn 20% less fuel. You burn 20% less fuel, you produce 25% less or 20% less CO2. Very simple. So this decarbonization can be achieved by not only moving from coal fuel to nuclear or solar, but using less energy to begin with, less energy. I was in a panel meeting like this 3-4 months ago with the energy minister from UAE, and UAE has a target by 2040 they will become carbon neutral. Use all oil today, all oil, all fossil fuel. 2040 carbon neutral. How they want to do this? They will use 40% less energy, 40% less than today, by using building energy efficiency. 40% less energy. Using 40% less energy means 40% less fuel, 40% less CO2. It's much easier for them to reach the zero carbon goal because they're using less energy. So I would strongly suggest in Indonesia, look seriously not only supply side, which is coal will be replaced by solar or wind, supply side. Okay, look at the demand side as well. Example, Pangoro asked, remote islands. Do not let them run their system like Jakarta does. A lot of lights for nothing. So let them work at their local situation, look at the local situation, and see how can they provide same quality service, cooling, lighting, ventilation, using better technology and therefore less electricity to run them. That would be my advice going forward.
Okay, thank you very much. Well, this is really new to us. So we are listening to your explanations on the smart grids and on the application to the smart building, even though the buildings are not very new, but still with some technicalities of the smart grid, I think that it will work very well. This is really something, Professor. Well, ladies and gentlemen, the audience, we still have about 5 to 10 minutes, about 10 minutes. Please type your questions in the chat, not raise hand. So we can read your questions for Professor Rahman. Please.
Just type your questions in Q&A section so we can read them. And
so many things are new. Probably the audience still thinking about this is something. This is something applicable. This is something from the future, but now it is offered in front of us, and we are still having some some contemplation on how this is gonna work in the near future. Maybe something like that, Professor. Well, as there is no chat in the QA, I'd like to also, on behalf of the audience, in your area there in the United States, especially in the Arlington, what is the percentage of the application of this IoT on the smart buildings in the area? It's already 100%, or not that 100%? No.
We have very good question. Very few smart buildings, very few where I live. I gave you maybe 4 or 5 examples. Maybe there are 10 more out of maybe less than 1% in the US.
Oh, really?
Takes time.
Why are they doubtful in applying this? It is because of the financing, condition, or because of the
issue is awareness.
I see.
People have to understand investing some money, the benefit you get. People used to normal life. They don't want change. That's
I see.
But you have to tell them the benefit, the value, then they slowly change their mind. I have a question in the chat box. Let me read the question. Is the cost of implementing building smart technology worth the power savings? Yes, it is. The example I gave you for that 70-plus-year-old building, we put the system there, the savings they got their money back in 3 years, as an example. It is worth the savings. In Jakarta area, Indonesia, because so much high usage of air conditioning in commercial buildings, you'll probably get money back faster because it's saving so much energy by reducing consumption from air conditioners.
In your presentation, it seems that smart building can also effect in our security system, right?
Yes.
This is also effective in the security system in the means that of for example, also so many criminals threat here to people, not only the health but also the physical well-being of the people. Is this not something seen by the people there?
Itu di mana? Ya.
What I'm saying is we have given you a platform, it's open architecture. You can bring in different applications in addition to heating and cooling in your case, and lighting, security camera, fire alarm, a rooftop solar, storage battery. All those things are good components to make the building not just healthy, secure. So that is my message. Make the building secure by keeping track of everything going on. That's what we like to see.
Okay, thank you very much, Professor. Well, are you living in one building, this smart building there in Arlington? Yes.
There are multiple smart buildings, but maybe 1-2% right now.
I see. Okay. Well, during this pandemic era, I think this smart building application should be very suitable, appropriate for this unlucky circumstances here.
There's a question.
Well, we are lucky. We still have questions. Well, we still have about 5 minutes. There's somebody here would like to ask questions from
Mr. Johnny
Aritonang. I'd like to read the question: how to anticipate the development of IoT in the future, especially with the existence of humans, which will certainly be replaced by robots. Oh, we're talking about robots to replace humans here. What do you think, Professor Rahman?
I don't believe humans will be replaced by robots. I don't believe that. You look at you people like yourselves, office workers. You can have a robot do your job. Cannot. A robot cannot teach my class. Cannot teach my class. I have to teach myself. Yes, in the factories, you replace some human labor with robots, but robots have to be managed, they have to be programmed, they have to be supervised. So I think the people will move away from busy work, that's probably true, and do more intellectually satisfying work. So even then, you can say, well, robots don't need air conditioning, right? They don't feel hot. But you need air conditioning to keep the parts in good shape. If the building is too hot, the cables getting stretched and they get problem in their operation. So you need ventilation for keeping the air quality at a minimum level. So even though you are not breathing as much there, but for the equipment you're using, it has to be dust free, for example. It has to be under some level of temperature control for the equipment you're using. So robots are not going to replace human beings in large quantities. No. We can do more things than robot can do for us.
I see. You mean to say that it happens or it applies on the movie only?
Or not only.
There is a possibility in the very far future.
We can talk about driverless car, for example. Driverless car, right? You don't need a driver. I'm not sure I'll not be comfortable sitting in a car, nobody's driving the car.
Okay, maybe that will be our last question,
Okay.
Professor.
Thank you very much, Mr. Johnny Aritona. I think we are coming to the end of this togetherness with Professor Rahman. Well, time is flying so fast, Professor. Well, it is easier to say hello than to say goodbye. Professor Rahman, I'd like to thank you very much for your contribution, for your presentation, for your everything is something what you did for us in this presentation of virtual conference. Thank you very much. We thank you very much. Well, audience, we are coming to the end of this session. Before saying goodbye, let's give a big applause to Professor Rahman.
Thank you very much.
Thank you so much,
Professor. Thank you very much.
Good luck for your election, sir.
And Dinus, wishing you good luck for the election. I would like to give some kind of concluding remark to the audience.
No, I think I enjoyed the questions that were raised. That shows that interest in there. But people ask me the same question: how many buildings in the US are smart?
Well, okay, thinking about this in the next presentation.
You should not wait for US to do it for you. Do it yourself. Now you know the technology. You know the people who can do it for you. So energize people. Yeah, I'm a professor. My job is to make people start thinking. Keep thinking.
Yes.
What can it do for the country? That's my parting remark for audience this morning.
Okay.
Wonderful,
thank you very much. You are a very good, very real scientist for the world. Thank you very much, Professor. Well, Thank you very much again, and see you. I'm wishing you safe and sound during these unlucky circumstances. We hope to see you again in the near future. Goodbye.
Inshallah.
Goodbye. Thank you very much.
Assalamualaikum.
Waalaikumsalam
Well,
warahmatullahi
this is
wabarakatuh.
all the presentation. Assalamualaikum warahmatullahi wabarakatuh from Professor Rahman audience. We're coming to the second session today. This is also a very, very outstanding expert with some other field here. This is from Dr. Muhammad Zazat Nazir. Well, ladies and gentlemen, I hope you start staying and very alert and also attentive to this seminar, to this conference. Coming to Dr. Muhammad Sajat Nasir, we'd like to say something to greet the expert. Hello, good morning, Dr. Nasir. Are you there with us already?
Yes, good morning.
Now you
Good
look very
morning,
great
sir.
today. You're ready to share something to the world. Okay, we'd like to say something first. Dr. Nazir is an expert in renewable energy. Renewable energy. Energy can be renewed. Well, this is really something. Dr. Nazir is from Huayin Institute of Technology, China. Well, Dr. Muhammad Nasir today is talking about the topic. Well, this is also another something. Renewable energy, challenges and opportunities. So we have challenges and opportunities of wind and electric vehicles development. Okay, before the presentation, Ms. Titin would like to say some introduction about our Professor Nasir. Please, Ms. Titin.
Okay, excuse me, Mr. Dr. Muhammad Sajat Nazir. I would like to read some brief bio of yours. First of all, Dr. Muhammad Sajat Nazir received his master degree in electrical engineering from Chongqing University, China, and PhD degree power system and automation from South China University of Technology, Guangzhou. Currently, he is an associate professor in the Faculty of Automation with Huayin Institute of Technology, Huayan, Jiangsu, China. He is also the member of Chinese Society for Electrical Engineering.
So from the slides that you will enjoy the slideshows of so many renewable energy. What is it? Energy.
Hello. Hello.
Oh.
Hello.
Hello.
Hello. Yes. Can you hear me?
Okay.
Yes,
now
I
it's
can hear you
clear
clearly,
now.
sir.
Okay.
Okay.
We can see your slide, but not you.
Okay. Okay. Assalamualaikum, and thank you very much for inviting me here.
Okay. Dr. Nasir, please make it convenient for 40 minutes for your presentation.
All right. All right.
Okay.
Okay.
Thank you very much. Please.
All right. Okay. Thank you. Thank you. First, I would like to say welcome to all the distinguished guests and the honorable director of the university, and special thanks to all the IEEE section, Indonesia, and also the Dr. Sandy, who was my colleague, and Guangzhou.
Bukan chat ya.
And so I would like to continue the presentation today as they have already introduced me. My name is Muhammad Shehzad Nazir, and I'm working as associate professor here in Huayin Institute of Technology in China, Jiangsu province. So today, I would like to discuss about the renewable energy, like which all of we know that is the very important these days. That I would like to give the reference of Professor Saifur Rahman as well, and he was as pushing us the communities that we would like would like to adopt the renewable energy. So today I would like to introduce some of the challenges and opportunities of the wind and electric vehicles development. So regarding this renewable energy, I will cover some of the topics that we'll discuss about the brief introduction of the wind, solar, and the smart grid and its application, or we can see its objectives, and the rules of the energy storage system and electric vehicles in the smart grid. As we know that the energy storage system is also very crucial because when we talk about the renewable energy, we know that the wind and the solar, they are intermittent, the nature of the energy sources. They're not the stable one. If we talk about the wind, I mean, wind maybe some of the places is in the not enough speedy that we can utilize it very well. Or if we talk about the solar energy, it's also like not available in the whole world. And sometimes we can say that it's only available in the daytime. I mean, night times, evening after evening, we can't use. So regarding this solar, the renewable energy sources, there's energy storage also very important. And then if we consider that decarbonization or the CO2 emission, that the electric vehicles is crucial these days, the whole world, especially where I am living in China, like electric vehicles are like rapidly adopted by the peoples of China, and I think almost the whole world, okay, to mitigate the CO2 emission and utilize the less fuel. I mean, there's a less fossil fuel. That is not like the beneficial for the humans' health and so on. So the smart grid, we all know, just we discuss about the smart grid as well. We know the smart grid, like to control or to utilize on the one place the control of all the load and then the load and demand as well. So that's the latest development. We'll also discuss of the wind, solar, and the electric vehicles and EVs and the electric vehicle charging. When we talk about the electric vehicles, of course, surely it is about the charging. So some of these days we'll discuss in details, like just for here, like the electric vehicles, we can say something like about 4 to 6 hours after the charging we can utilize it. So we also have to enhance, or we have to increase or to utilize some new materials for the charging purpose. So then it can will be confident of this technology to replace the fossil fuel based vehicles. And then next, like we'll discuss about the impact of the wind and the electrical vehicles, the charging on the power system and planning and the operation as well. And at the end, I would like to conclude like some of the give my suggestions. Okay, so let's see here like what's happening in the world and in the past. Like here we can say locations of the blackouts, some examples affected by the over 5 million people in the past. So that was we can say that most of the fossil fuel based the power system, that we can say some of the examples like from 2003 we can say, and Italy, the blackout, that 55 million people affected by that. And then next that we have, that is the in 2003 as well. That's North American, that's the Northeast blackout, and same the 55 million people's also affected in that blackout as well. So we have here back this one 2001, 12. Okay, so in this one we can say that there was in India there's a blackout, and 230 and 620, and that's a million people's affected and respectively in that times. And then let's we in 2000 like the 9 we can say that's it was the Brazil and the Paraguay, that's blackout that we have the 87 million peoples as well affected in that blackout. So of course that all these blackouts, it was not like the in the favor of the energy, the users, and the humans. So then next that was we can say about 2005 as well. It was in Indonesia, yes, and in your country, like it was in the Java Valley. That's a blackout, and 100 million people that times also affected in that times. You all might be the witness of that one, most of you. And then is 2014. That's in the Bangladesh. Okay, that's blackout. There's 150 million people as well affected. And next that we can say 2015, that's Turkey, that's in the blackout, and 70 million people affected in that blackout. And the same like it is in my country, that's Pakistan, 2015, there was a blackout, and 114 million people was affected in that blackout as well. So that was some like the overview, like what happened in the past about this because of the energy. So that was the preview, and here we have the energy technologies, the trends in the future. We can see in the future, just know as I said, like about that the vehicles we are utilizing, okay, and the other side energy storage, okay, and then these days we're also using the artificial intelligence, AI techniques, approach, and energy system, and we have IoT. Just Professor Saifur Rahman, he already details and he said. And meanwhile, we also using the platforms and business models, okay, and the different ones. We can say all of these one they're also utilizing, and aggregators, the VPP, and the blockchains as well. So beside this one, we can say from here we have the electrification of the end use sectors. Okay, behind this one we also have the massive expansion of the interconnection and creation of the regional markets. Okay, so here we can see there's that side we can say it is the system operation. Okay, in that side. And all these are based on the renewable technologies, we can say, and that we have the value of the complementaries and the renewable energy sources. On that side, we can say that is the market regulations. We also have some of the market regulations that we still have to extend and enhance these market regulations because of the renewable energy technologies, the integration of the renewable energy technologies. So we have the decentralized system that's through the distributed the generation as well. And the other side, we have all this. So in this way, we can say that in the future, we have the innovation trends for the future power system. So what will be that one? We can say that is the digitalization. Okay, first one. The second one is the decentralization. Okay, and then we also must have the flexible system in the future. And as well as we have the electrification, and that we have that of the end of the use as well. So here, as we said, the renewable energy. So I would like to say that the wind and the solar energy development, I would like to say like some of the data I would like to show you over here. That here we can say from 2010 to 18, I collected some of the data I would like to share. That was about the wind, and here we have the annual capacity by the region. Okay, that's we have the 2010 to 18 data in here. Like different countries, we can say that here is like the Asia. Okay, and then we have next one, that is the say Middle East. Okay, over here and there are some countries, Africa and the Middle East, and the Europe we can say, and then is Latin America, and also the North America as well, and the Pacific region as well. So here all of we have some data. So we can say the wind in 2018, that's increase in the wind generation that was equal to the almost half of the global load demand. We are talking about the wind growth. And the new installations we have in the only in the China, okay, just like the you can say only in the China that we have the 30 gigawatts, okay, 30 gigawatts. And if you talk about the the global, that was a 63 gigawatts. So we can say the half of that one it is in China. And other side, if we talk about the solar, the photovoltaic generation, that's the capacity, the gigawatts. We can say all this one. We have these values from the Japan, okay, and then we have the Germany, and the top, and then we have the US, Spain, Italy, and then China is also over here, and then rest of the world as well. So many countries they are also like focusing on the on the renewable energies, including the wind and the solar. So the photovoltaic, the we are saying the solar energy that from 2003 to 18 that's installed that photovoltaic increased from 1.3 gigawatts and to the 187 gigawatts. And the five countries, only the five countries, like they account for almost 70%. Okay, that's including China, USA, Japan, Germany, and Italy. So only the five countries. So rest of the world is also like some countries those who have been blessed by this energy. So they are also utilizing, of course, in that way. And some key that problems. We also have the problem for this one for adopting this renewable energy sources. So we can say that due to the large scale renewable energy sources, that integration, of course, there's some problems as well. I mean, some issues which are facing. Yes, we can say the temporal mismatch between the generation and the demand due to the system uncertainty. At in the beginning, as I said, because that's we already have the conventional system, so it is not easy to, of course, couple with them to integrate together and integrate them and to use it, utilize it and to use it together. So that is, and also the system demand and the generation, because this is also one of the issue that the fossil fuel based energy in this way, we can say it is good, because it is, we can say, the constant of we can get the output. But here in the renewable energy sources, as we are talking about the wind and the solar, so we can't have that one as we discussed. The solar energy is not available at after evening, and so we need to have some other approaches like the energy storage devices. And if we talk about the wind is also not constant speed, so we have the uncertainty of these both renewable energy sources. And we have a transmission and the congestion that's due to the increased wind and the solar power as well. And we have the bidirectional, the power flow, and the distribution system due to the distributed generation as well, DGs. So that here we can say the use of the smart grid, okay, the application of smart grid, we can say the intelligent electricity infrastructure that uses the technology that we can say such as the sensors, communications, automations, and the computers to improve the flexibility and the reliability and the efficiency of the electricity system. So these days, the smart grid, it is very useful and very we can say the applicable is very attractive these days. So we can say that overall we have here from the system we have the provide the high the quality power, one of this one, okay, and the other side we can say that the consumers to participate in the operation of the grid, and both will be together. And other side we can say is a self-healing, okay, also the self-healing, because this when we call it smart or the intelligent one, so it can self-heal, it can like give us the advanced especially when we talk about the wind or the solar, it can give us the advanced using the AI, artificial intelligence. It can provide us the advanced that's wind speed, so we can say predict the advanced the wind speed, so we can use some other the standby by the systems as well, so accommodate all the generations and the storage options. it can accommodate. I mean, we can say use the energy storage devices and so on. And next we have the enabling the intermittent power generation sources. Okay, so in this way we have also that it can enable all the energy resources. We can have the storage, we have a smart meters and residential consumers as well over here. And then we have the electricity markets will flourish as well. In this way, if we utilize that's the renewable energy in this case. So we have the operates the more efficient way. Okay, by utilizing all this, we can have the utilize the more efficient way as well. So that here is like the broad picture of that one of the smart grid and the centralized grid. Here we can say from here we can see from the smart homes, okay, and then all the connected together and the one place. If we talk about this one, we can also say the factories and the industrial loads, and we have the nuclear power plants, and we have smart vehicles as well, and we have the solar and the wind and other biomass renewable energy source and so on, and electric vehicles of course that we have, and then we have the smart cities as well. Smart cities, it can also be interconnected and together that we have the smart homes as well over here. So here we can say that if we say the smart grid realization with the full application of the PE and the ICTs, okay, that we can say power electronics, I mean, and we have that's ICTs as well. So we have the long distance and the large scale, the power transfer, so we can say in the grid. From here we can say the mixed generation sources. Okay, all of this one I'm trying to like that's so about the focus on the renewable energy and the smart grid, or we can say the microgrid, different intelligent, and we can give the name on the different way. Okay, that we have that is about the mixed generation sources that we have with the grids, okay, connected and in and out the information. And this one we can say this one the circle of that one is representing the PE, the power electronics interface. Okay, we can say the conversion of the energies, like we can say AC to DC or DC to AC and so on, inverter, converter, and the power electronics interface. And that one we are representing by the power flow as well with that one. And here we have that's the information flow, because when we talk about the smart grid or this one macro grid, so we must have the information transformation. Information flow is very important in this case. So then we also have the information and the communication technologies, that ICs, information and communication technologies, and this one is representing when we talk about the information flow. So we are talking in the information and the communication technologies of the application. I mean, we can say IoTs and so on. And then on that side we can say HVDC or the MVDC. And that side we have to utilize the FACT or the defect devices. Okay, the FACT devices we have to utilize that one. I mean the shunt and the parallel systems for our transmission sides mostly. So in that side we can say the flexible power flow control is that one, flexible AC transmission system. And then we have the demand responsive, that's a load, DRI. And that side in the future, I mean grids, we have the electrical vehicles, and then we also have the distributed generators as well, we can say the DGs. And based on this one we can utilize from here directly. I mean that one is increased the renewable energy sources and the penetration. Then we say that is the energy storage system, that ESS as well, that we have the. So all these are the smart grid. We have the realization that we have with the full application of the power electronics, and we have the information communication. So all these are together on the one place, and in this way we can say that is a smart grid. So the energy storage system, that is one of the main the element, or we can say the component in that smart grid. So we have the smart grid as well. So we have the why we I mean sometimes the people say that why we use to the energy storage systems, energy storage devices. So that is very important and need to understand for the community, and awareness is also very important in this case. So we can say this is the intelligent the integration of the renewable energies. Okay, we can say is the intermittent. Okay, so we have the wind and then we can say that we also have the services, and that we have the managing the peak demands. Okay, a peak demand of this one. And energy storage systems play the several roles in the different parts of the power system. So first that we can say is the generation side, okay, the energy storage on the generation side. On the generation side, we have the time shifting, okay, and this is the advantage. We have the output smoothing. I mean, based on the energy storage, we can have this one, the time shifting as well as we have the output smoothing, and we also have the capacity forming as well. And if you talk about the grid side, I mean, after the generation, we have the grids in the power system. We already know that is. And then we can say the load leveling. Okay, the load leveling, that is very important as well. We have the frequency regulations, and we have the inertia emulation as well. Then we have the voltage control. Okay. Then we have the load leveling over here. Then we have the peak shaving over here as well. And then we have the inertia emulation, voltage control, low voltage right through LVRT. That's the students or the researchers, LVRT, the electrical engineers, they already know this, the sport. And then we have the operating reserves as well. And the transmission utilization efficiency. This is also one of the benefit of the, we can say, the grid side the system. Then we have the demand side, okay, that is, we can say, supply and the demand side. So demand side management as well. In this way we can also regulate, or we can say we can use in the better way of this the demand side we can control. Next, that we have the existing, the capacity of the energy storage systems. Okay, the existing, we have some storage capacity, and then we also have to enhance this one, expand this one. So total energy capacity, we can say it is a little bit the old data, so we can be updated by this one. And we have the almost like 140.976 gigawatt, 3.2% of the total generation. Okay, that's about 4,000 gigawatts. And we have the compressed air energy storage. Because we have the form of energy storage, we also have this different one. We have the batteries, we have the flywheels, and we have the some, like we can say, the air energy storage, and some other techniques as well. So we have the compressed air energy storage. It's about 440 megawatts, if we say. Then we can also say the sodium sulfur batteries as well over here. And then we can say the lithium ions battery also over here, about, which is contributing about 100 megawatts. And then we have a lead acid batteries as well, that is contributing about 70 megawatts. And if we talk about the flywheels, we have the 25 megawatts, and including there's nickel cadmium batteries, that is about 27 megawatts, and redox flow batteries. Okay, you can be operated with the present data. It is a little bit old data, so I'm sorry for that one, but still I can give you some of the ideas about this one, that how much the capacity is already is the IEEE, the ESS energy storage systems as well. So overall, we have this one, that's the pump hydro with 140 gigawatts, about 10% of the total storage capacity. The pump hydro is the most of that one. So we can say that it is insufficient to address the high variable and the uncertainty and the renewable generation, and a more cost-effective solution is needed as well. Okay, we cannot say that I mean, these days, as we are talking about the very rapid growth of the technology, so we cannot stop on the one technology. We cannot say that that's enough. We need to continue. I mean, continue to find the better solution of our future for the humans, and for the better human life as well. So we have the electric vehicles and energy storage systems, that over here we can say in the energy storage systems, that we can say in the lead acid batteries, I mean, most of them. And then we can say that we have the many of this one, we have a fuel cell, and so other approaches as well, other techniques. So, but here I would like to only give the little introduction about that one, that we have used in the electric vehicles, most of this one, that is a high power density, these both approaches, I mean, the Leon batteries and the lead acid batteries. Then we have the high power density and the high energy density as well, and the fast response over here. We can say the long lifetime, and the probability as well. So we have a different of this one. we can say the ratings density is based on this one. It might be like some other approaches and some other type of the batteries as well. And based off, I mean, this research are based on this my group research, that we can see the ratings and the density. We have the response time, and we can say the efficiency and the self-discharging, that we can see the per day and the lifetime per year. We can say in the year, sorry, that we had the cost at the end as well in the dollars. So on based on this one, we concluded this data. And type of energy storage, we discussed that we have the different type of energy storage. We have the this way we have the discharge time at the rated power, and we have the system power ratings and the module size as well. That we can say the reserve and the response services. Based on this one, we have the high energy supercapacitors, and we have nickel cadmium the batteries or energy storage devices as well. And if you talk about the transmission and distribution of the grid support, that we have the flow batteries. I mean that we have the sodium sulfur battery as well. We have advanced lead acid batteries and the lithium batteries and so on. And the main important that is we have the flywheels and the high power the capacitors. Okay, and then we also have in this case the super, that we have a conductive, that's the magnetic energy storage as well that we have. And if we talk about the bulk power management, that we can say the pump hydropower storage, and we can say the compressed air, the energy storage as well, and then so on. We have all this one. So key, like the type of the energy storage we have, that's mostly it is related, that we have a different approaches, that we have the hydrogen related, and we also have the mechanical related, and as well as we have electrochemicals, of course, that is related, and the electrical surely, and then we also have the thermal resources as well. So on based on this one, just we said the lead and the acid batteries on the electrical vehicles, based on mostly on this one, these two approaches. So if you talk about the motivations for the electric vehicles adoption, that we have the transportation sectors that accounts for the 27% of energy use worldwide. Worldwide, if it is 27%, maybe this time it will be more than this one. Okay, as the last previous, like we can say the half decade, is electric vehicles is rapidly increased, especially in the US, and we can say also in China and some other countries as well. So worldwide, we can say simply that the world energy consumption that we have in the US, that we can say it is the like industrial is 52%, and the commercial is 8%, and the residential is 13%. Okay, and the transportation is 27%. Okay, we have just one the case study of the one of the country. We just gave one data that we have the transportation energy consumptions. Okay, that we have overall, we can say the oils products. Okay, so it should be like replaced. It should be replaced, reduced. Reduction is somehow not possible. So it is increased actually. So we need to reduce that one. That is red side, 93% oil products. It means like we can say the fossil fuel based. And the others we have the like the biofuels and the waste and the coal, and then we also have only the few one is a natural gas and 3%. So that's a global, like we could talk about the emission, that we can say CO2 emission from the fossil fuel, the global carbon projects. We can say from the 1990s till today, and like till previous year, we can say that mostly it is increased. That's good. Actually, that's a good one. But we can say if it is in 2013, it was better to 2.3%, 3%. But here we can say that it is 2.3%. It still need it still need like the some more addition, or we can say duration of this one. So that one we can say, from that we have the trend of the global means, that we have a temperature anomaly, that we have the NASA data. It's about a 5 years mean. We can say that it's also increased from the 1990s to forward. So the outlook of the electric vehicles and the globally, that's we can say the globally numbers of electrical vehicles reached 1.52 millions in the 2018. So this amount is 100 times greater than that in the 2012. So it is a good sign that for the electric vehicles, awareness and adoption, and the people's confident on that one. So that is good sign towards for the human's life, or to reduce the CO2 emission and so on. So that we have the global electric vehicles deployment until 2020 that we have is it was like 20 millions. Okay, and it is a different countries data is available here, that we can say Netherlands, UK, US, Canada, France, Japan. Okay, and then some other countries as well. Then we can say there's China as well is over here. So we can say that mostly in the US and the China mostly is on the like the electric vehicle sales in the market. Actually, adoption is also okay, but China is also producing a lot of that one, the electric vehicles. I mean, one of my group that is also working on the electric vehicles as well. We have some good applications on these electric vehicles as well. So that's the sales and the market share and the sum of the leading countries. Then we can say mostly the China, US, Netherlands, Norway, UK, and Japan, and Germany, France, and Sweden as well, and some other countries as well. So that we can say the electric vehicles traveling range after the fully charged, we can say some of this one, and like for the sedan, this is one of the brand that we can say electric vehicles ranges only 160 kilometers to 200 kilometers. So this is also one of the reason that the intercity usage is fine, but for the long range, the people have not much confidence about to utilize these vehicles. So this needs to be more research. This needs like more one and some hybrid electric vehicles. We have different companies that we have. One or the someone is 300 kilometers or even more. And if we talk about the racing, that is 430 kilometers and some taxi, okay, and that we have we have the 4 seats that is range about only 300 kilometers as well for a typical shift. I mean, intercity, that's for the people utilization of adaptation of this one, the electric vehicles is good, is a positive, but for the long range, of course, for the other cities traveling, that is not the feasible one. That we can also say that we have that's for the buses, we also have that's electric vehicles, that are buses that we can say that is KMB single desk air conditioned bus, that we have a number of passengers is 66, that it can travel 180 kilometers as well. So that we have the charging times of this one. So this is also one of the factor that we have from the sedan electric vehicles. We have the slow charging, 7 to 8 hours, and so this is the longest time. I mean, that is also one of the factor that the people can't adopt, actually, that can't not confident to utilize this one. So still much research is needed in this sector. And the semi-fast charging, that's 2 to 3 hours. It cannot be still acceptable. That's a quick charging, that is 30 minutes. I mean, still improving. So that's a good sign. And in this field, about electric vehicle charging, time reduction is good. Then we have the for BYD e-taxi, that's the normal charging, that's 2 hours. And we have from the KMB e-bus that we have the normal charging is 3 hours. So still much research is on the way, that we can say that here we have the Tesla Motors, a successful electrical vehicles manufacturer. That's the Tesla Motors, that we have the Tesla Motors is an American company that's founded in 2003, that's which designs and manufactures that electric vehicles and the battery products as well. So here we can see there are models over here. There's electric vehicles models and the batteries and capacity that we have, the average range, this one. Then we have initial price of that one as well, and then we have a mass production, that's the start years, you can say. So we have the lithium ions that we have a 53 kilovolts hours. We can say that one is the first roadster. We have 390 kilometers of that one is the average range, and its initial price is over here in the dollars, and then that is the 2008. And then we have a Model S, X, and the Model 3 as well. So all these models we have, there is a battery range and the lithium ion battery we utilize, and here also lithium ion batteries. Okay, that we have a lithium ion batteries and so on. All these lithium ion batteries usually are adopted over here. And average range, we can say that's 390 kilometers and the 420 kilometers. I mean, that is the good range. Okay, and then We can say the 410 kilometers for the X model, and then we have the 346 kilometers for the Model 3. So we have that the Model S is world's best selling the electric vehicles in 2015, and the Model 3 has more than like we can say 305 that one. So of the April 2016 in this case. So that was, and if we say the vehicles that we cannot say the EVSE is required to act as an interface between the electric vehicles and the power grids. So that's all about the about electric vehicles and some of the introductions about all these electric vehicles and the equipped and the EVSE, so on. So that is I think it is going to be over. So that one, all of that we have level 1, level 2, and DC first. We have the some of introduction over here. So electric vehicles charging, we can say that one, and electric vehicle charging and the manufacturing and the different countries design and their electric vehicles, different vehicles, so on. We have different models. Let me. I think time is almost over. So let me. Okay. Okay, that's we have that's the integration. That's the integration of that one of electric vehicles into the electric power grids. That we have the large-scale adoption of the electric vehicles will pose the new challenges and the opportunities to the power system, and in the different levels. We have the uncontrolled and the integration of the electric vehicles, and then we have the uncontrolled electric vehicles that we have the load profile change due to the uncontrolled electric vehicles. Here we have given this data for the challenges which are facing the electric vehicles. That we have distribution, the equipment, and the overloading. That's the voltage drop. That we have the loss. That's the increase and need for the investment in the grid reinforcement. And we can say, and the transmission. If we talk about transmission, then that we have uh, that's the congestion in the lines and need for the investment in the grid, and we have the generation as well. So we have the integration of the electric vehicles, wind into the electric power grids. I think my time is up almost. Okay, let me. Okay, like at the end, I would like to like. Okay, that's just useful some data which we have published, and some of the and the good papers about environment impact, and that we have the pollution related challenges of the renewable wind energy paradigm that we have. It is that in the 2019 that we have in the Q1 journal. That's the sense of the total environment. We have the group publication that we have. The other one is the energy and environment. Is SCI journals. We have the publication from our group that we have wind generators, and then we also have from my other group we have the potential environment of it's one of the good journal. That's the current opinion in the environmental sense and the health. Then some of these my publications you can check in from our group. So I would like to conclude my presentation over here. That's renewable energy usage, that we can say that address the increasing the concerns about the energy security and the fuel and the diversity and the climate change. And so we can say the electric vehicles, and that is the high key. key component in the power grid for the balancing the variations of the renewable generation and the improvement, the flexibility of the system operation. And then we have the progress and the massive usage of the electric vehicles depends on that we have the advanced batteries. And then we can also so that's it. That was about the conclusion that we have. And then the progress is a massive usage of electrical vehicles that depends on advanced battery technology. There's a longer travel distance and that we have, and advanced battery technology that we have the higher power charging and technology that's a short charging time. And we have the mass production, lower price of electrical vehicles, and the smart grid technologies such as V2G, vehicle to grid, uh, that we have the low operational cost of the electric vehicles, and as well as we have that about the improve the system planning and the operation support for the massive electrical vehicle usage.
Gimana caranya kita mengingatkan?
Smart grid are key enablers for the increase the usage of the renewable energies and to address the operational challenges that's faced by the power utilization due to the that's a high there's a variability and uncertainty in the renewable generations. So that's here I can conclude. And so at the end, I would like to say that global trends of the wind and the electric vehicles usage is reversible, and electric vehicle charging is important to support the massive integration of the renewable energies in the smart grid. So thank you for your patience and listening. There might be some, I think, the problem in the beginning. I'm very sorry for that one. And okay, that's it for me. Thank you.
Zat Nazir?
You and me. Thank you very much for the presentation. Can you hear us? There is some technicality problem here. Can you hear us now?
Yes.
Yeah, your slide presentation is very clear. No worries. Yeah, but can you hear us now? Hello?
Yes, I can hear.
Okay.
Sorry for that.
Thank you. Thank you very much. Thank you very much. We're still watching you, but not. We are not. We are here having some technical problem. No, now it's settled now. Well, we have now still 15 minutes for QA session. Okay, we have asked the audience to type something on the QA, and then after we call the name, we can they can raise hand. Okay, now we have somebody here for the first question from Mr. Johnny Aritonang again. Wow, this is very active participant, right? We'd like to read the question here. How do
Raise hand, please, maybe, Mr.
raise hand.
Johnny
Okay.
Aritonang.
By Mr. Johnny Aritonang himself, maybe raise hand. So we will give you the platform. We'll give you the floor. Okay. Okay, would like to read. How do EV and WV compare in terms of advantages and disadvantages, especially in the terms of road safety? Will the EV or WV battery be recycled if it is damaged or unused? Is that clear, Professor? Is that clear, Dr. Nasir? Yeah.
Yes, I can hear. Actually, like the electric vehicles, when you talk about the electric vehicles, I would like to say that he mentioned there's a road safety. Actually, there's no problem for the road safety. It is same like the other vehicles, same as other vehicles. Same, we use the hybrid vehicles. We utilize the hybrid vehicles and we use the other vehicles and the fossil fuel based vehicles. That's not a problem for the electric vehicles. But I'm not sure about the what is WV. What does it mean? Electric EV is electric vehicles, but what is WV? So sorry, I'm not clear about it.
Okay,
What is
maybe
WV?
Mr. Juni Aritonang can explain a little what EV
WV.
means.
EV is electric vehicles, but WV.
But
Electric
WV, WV. Okay, WV. What is WV?
Mr. Joni Arito, now what is WV in your mind?
Yes. Oh, wind actually, yes, wind is not a vehicle. Wind we are using as an energy source.
Oh, I see. Talking about the
Yes,
wind. Wind is not vehicle. Yeah.
Wind is not a vehicle actually. Actually, wind is not a vehicle. Wind we are using as an energy resources, as an energy source.
Energy resources.
Yes, energy resources. I mean, the wind and the solar, we can use as energy resources, and we can energy storage. We can store that energy, I mean, in the form of the batteries, okay, in the form of the energy storage devices. And that energy storage devices can be utilized, I mean, in the form of the battery. We can use that's the batteries in our electric vehicles. I mean, electric vehicles means is not the unmanned vehicles. It is like the it's not automatic one, okay?
Yeah.
It's not the unmade one, okay? We will just use the batteries, I mean, the same like the petrol and the other fossil fuel based vehicles. We just replace the fossil fuel with the renewable energy resource with the batteries. So less, I mean, we're going towards the carbon emission, I mean, decarbonization, because the fossil fuel is one of the harmful part to generate the carbon, okay? That's not good for the health. So that's why we are saying that we can use the green energy. I mean, we can say the renewable energy, wind and the solar. Okay. And that's wind and the solar we can utilize as energy resource. And then that we can in the form of energy storage. And that energy storage can be the vehicles batteries. And that batteries we can utilize in the electric vehicles. That was a concept. And the other one is that he just recycles. He said the other part, will the electric vehicles battery be recycled if it is damaged or unused? Yes, of course. I mean, this is also in the good question that it will be reused. Okay, it will be recycled. Okay, that's why we can say it will be not the harmful for the humans. It will be, of course, it's not like the same as the wind or the solar, because we use some materials which are not good for the health as well. But still, research is on the way that we can recycle it, we can utilize it. Okay, and the damage is not the much damage. We are already using the batteries. Okay, we are already using the batteries in our vehicles. We will just use as a fuel, as energy storage batteries.
Okay. The next questions.
Okay, maybe something to confirm from the wind resource. Does it need some kind of what is it requirement that there should be some flow of the wind, or a static wind is also applies in this vehicle? Sometimes wind is blowing very fast. Sometimes there is no wind. What do you think?
Yes. That's a problem actually. That's a challenge for the wind energy.
I see.
And also the solar energy. This is of course a big problem for the issue of both of the energy resources. But that's why we are saying that that's why my focus was on the energy storage as well. I mean, not only the energy resources, also the energy storage. So energy storage means when there's a maximum wind, I mean, when we have in the term in the MPP, maximum power point tracking. Okay, so that one when there's a maximum wind, we can extract and we can generate the energy by utilizing the wind power, wind turbines, and then we can store it and the DC form in the batteries. That one, and the same as for the solar, that we can have the energy storage. Okay, and then that energy storage we can utilize as a form of the batteries, or we can utilize it.
Well, okay, I hope it is clear for Mr. Joni Altonang and for us. Thank you very much, Mr. Joni Altonang, for the question. Now we're coming to somebody else. We have Ms. Florence Agnes. Okay, the question is, what is the shortage and advantage of such technologies? Maybe besides the damage or besides the, what is it, the low competency? Yes.
Yes, actually, that of course, all the technologies we know that all the researchers, the scientists, we the students already were studying about it. That's all the technologies. They have some shortcomings or the disadvantages as well. We also have some disadvantages. Surely we have. I mean, there's a uh, there are many like many of the shortage as well. But the problem is this when we compare the efficiency actually, because when we adopt any technology, we can adopt it on the base of the efficiency, and we can compare with the previous technology as well. I mean the previous resources as well. So when we get these technologies, we can say the wind, solar, and we compare with the energy storage devices, electric vehicles. I mean these were my keywords for my speech. So we compare with the conventional system, the fossil fuel based system. So efficiency is somehow we can say it is better if we say about the talk about the fossil fuel based, but the disadvantages of the fossil fuel, that is more than that's the renewable energy technologies. So when we compare it, so we can say that is the better technologies, okay, especially when we talk about on the our root or the basis on the human life, or the that's humans like the betterment of the health. So that's why we can say that the new technologies such as the wind and the solar, they are the actually this is from the nature as well. Okay, it's more easy than I think we can say from that one, from the fossil fuel based technologies. We can easily install, and we can easily like anywhere. Okay, that's mostly like there's a place for the wind and the solar. We can install it, and we can extract the energy from them, and in the form of the energy storage we can utilize it. So that's why we can say that there are shortcomings, but still is the research is on the way. And electric vehicles in the same way, there are also, of course, as I told you, that's one of the disadvantages is this one. That's a long charging time. That's one of the disadvantage. Okay, and we can also say that less we can say the distance of the traveling, we can say is a 200 or 300 kilometers. I mean within cities is possible, but if we have the like long distance, then of course it's not possible. We still have to utilize it, the other source of energies. But still we can say these days, if we look around that in many countries, we have some others as well. That's we can say electric traction. Okay, that we're utilizing the fast speed rail trains. We are utilizing these batteries.
Okay,
So I
Dr.
think
Dr. Nazir, thank you very much. There is one very interesting question here. This is also due to some event about the flood. Can we drive and charge the electric vehicle even if we get caught in a flood? So what is our solution when we get caught in the flood, and then the car or the vehicle is caught in the flood, and then we are not going anywhere?
you mean the flood, right?
Yes, we are caught in the middle
Yeah,
of the flood.
a flood. I mean the river, right? The flood water.
Yeah, the flood on the street, probably because of the sudden flood happening after the hard rain.
Mm-hmm. Yes, actually, like all these technologies, they are in this sense because we are talking about a natural disaster, something like that. I mean, this the flood is a disaster, kind of a disaster. So on the disaster, we have some safety measures for these electrical vehicles, that for many of these we can utilize the new technologies, the covering one for that one. I mean the electric vehicle is the same as other vehicles. I mean there's not such much difference. The difference is only is a better way that we can utilize the green or the clean technology. Okay, is only is that one. Other is almost the same. I mean there's not such a much difference in the flood. I mean the same like the other vehicles, what they will face the problem in the flood. So the same the electric vehicles, that it will face the problem as well, I think.
Okay, that's not the problem in it, Dr. Nazir. Another problem happening due to these electric vehicles. Suppose there is a
Yes, of course.
situation like this. A situation like this. Many people say electric vehicles will be used mass in the future to replace fossil fuels.
Excuse me,
We out.
Yes, yes, I can
Yeah.
hear.
Okay. To replace the fossil fuels, of course, the fossil fuels industries will be collapsed, will be collapsing and will be disrupted. So, and then if the sorry, technicalities problem.
I can hear you. You can continue, please.
Okay, but the question is lost. Wait a minute, please.
Oh,
Yeah.
okay.
Okay. What will be happening if the petroleum industries are also disrupted and they cannot produce fossil fuels, and then everything is depending on the new energy. And you know that the petroleum industry is also mostly used for any other business, any other enterprises for also making some other energy. What do you think?
Yes, very right, right, and the interesting next thing. Yes, the both are in the parallel way. We can say the parallel way. The both technologies, we can say the renewable energy technologies and the fossil fuel based the technologies. They are on the parallel. But actually, as a researcher, as a like the student of these energy technologies, that we can say that this is not like some big problem for the fossil fuel based that one. We still have that one, and they can utilize the new technologies if the researchers who are doing the research in that field, if they can reduce the impact, okay, the pollution impact or the environmental impact of that petroleum, like the fossil fuel based energies. So of course then it can be worked together, okay, it can be still they are working together, because it is not easy to replace the fossil fuel based, because it also have the many good that's advantages. Okay, fossil fuel based energy sources. So we are not like that they are just going to replace the 100%, of course not. It is not possible actually, and if we practically, the
I
answer is
see.
very
I
right.
see.
It's not possible.
Yeah.
They can also adopt, yeah, that technologies. The fossil fuel based technologies, energy generation sector. They can also adopt some of the new approaches, new techniques to reduce the pollution, to reduce the environmental impact. So in that way, they can be like the friendly, like both can work together. That they're not.
So we are talking about composite shares, yeah, not the domination, not the dominance of particular energy, but we are contributing to the share, right? This is also
Right.
maybe probably also influenced by the world politics. For example, if the fuel dominates, I think the other resource also not very happy. If this new renewable energy dominates something, the former dominating energy is not very happy. There should be some kind of balance on the share or something.
Yes, actually, as you said, is right. Some politics is also involved. Like some countries, of course, which they are rich in the fossil fuel energy sources, which they are rich in energy resources. The fossil fuel based energy resources. So of course they have something to do. They are maybe still doing for something, like they don't like to replace their the energy, or they are not like thinking in that way, the way which the other side are the renewable energy researchers are thinking. They have also they can do the, but as I said, actually the important point for both of the technologies is that, because though both are from the nature, and they can adopt the technologies, okay, they can reduce I will be on the same point, that they can reduce the impact of the polluted impact of the environmental impact actually. So then it can be balanced. It can be balanced. Politics isn't involved until it is the neutral way. If they think only about the humans, of the human's life, and the betterment to the better way of the utilization of the energy sources, then of course there will be no conflict. But if some government or the politicians have been involved, then of course then it will be a mess. So that is, yes.
Okay, Dr. Nasir. It seems that you are what is it, getting so many questioners here, but one more question to close this session. Well, you are very favorite here. Okay, we're talking about the electric vehicles. Okay, let's say electric cars. Do you think they can overheat? And what will you do if overheating happens? is it able to overheat the electric cars practically and also scientifically? What do you think?
Actually, the if the thermal engineer, I mean the other mechanical engineer, he can give the better answer for this one. But according to my research, our research, I would like to say that because our focus is only on to enhance or to increase that the betterment of to adopt the renewable energy technologies. So of course there will be a heat, we can say the problem, overheating, but that much not will be that will be we can say that it will be a very difficult situation to handle it. We have
Oh, I
we
see.
that we can say the radiators, or we can say the like the in the we can utilize in the motors we can use some kind of materials which can reduce,
I
like
see.
same way we utilize in the transformers, like we can use from the oils tank to reduce to cool down of that one for the transformer the operation. Okay, in the same way we have some approaches or some techniques in the electric vehicles to reduce there's heating problem or something like that.
Maybe the electric cars is already rampant everywhere. Most people use the electric cars, and then overheating happens. So overheating will be some kind of new research on this kind of issue. You think so?
Might be. Yes, might be.
So this is your homework. What will happen if overheating happens in the future? Something like that.
Yes, it is something like that.
Okay, thank you very much, Dr. Nazir. There has been some kind of very great presentation as well as discussions, and there are more of the audience asking questions, but our time is limited. Well, we appreciate your being here. We appreciate your thoughts shared to us together to the world of the technology, information technology. We would like to appreciate this very much. We thank you very much. We hope to see you again. We hope to look forward to your more researches in the future and coming back to Dinus University. Promise us.
Thank you.
Promise us.
Sure.
Okay.
Inshallah. Yes.
We're waiting
Inshallah.
for you, sir.
Okay, ladies and gentlemen.
Yeah, still my email is there, and if some more questions they can send me by email. I would be happy there to answer after all the questions.
Well, thank you very much. Before we closing the session, would you please give some kind of concluding remark or concluding statement of your expertise here?
Sure. I will share with yes. Yes. Thank you. We like for this all this invitation, and there's such a nice conference, and congratulations for this one, and hope to see you like meet you soon.
Okay, thank you very much. Well, ladies and gentlemen, let's close this session. Give him a very big hand. Thank you very much. Well, this is half of the day of this conference, ladies and gentlemen. I hope you're still staying to the end of this program. I hope you're still attentive. Or you can drink something or have something at your own respective homes. Okay, now we're coming willy-nilly to the third presenter of the day in this Isemantic. This is also, we're coming to a very noted professor from Indonesia. We would like to greet first Professor Gamantio Hindratoro. Good morning, Professor. Are you here?
Yes, good morning. Yep, thank you.
Wow, thank you very much. You look great today. How are you?
I'm fine, thanks. Alhamdulillah.
Okay. How is Surabaya, Professor?
It's quite hot right now.
Usually after the heat, there will be the rain.
Yeah.
Thank you very much. Thank you very much. Before your presentation, we would like to say something. Professor Gamantio Hindratoro is an expert in wireless communication and radio waves propagation from Institute Teknologi 10 November Surabaya, Indonesia. before the presentation, we'd like to show you, to present to you some introduction about our Professor Gamantio here. Ms. Titin, please.
Okay, Professor Insinyur Gamantio Hendrantoro, Master Engineering and PhD from Institut Teknologi 10 November, Surabaya. Received bachelor degree in electric engineering from Institut Teknologi 10 November, Surabaya. Kemudian, and then Master of Engineering in Electrical Engineering and PhD in Carleton University. Besides being lecturer at Institut Teknologi 10 November, Surabaya, he has many achievements such as won the Young Scientist Award from the International Union of Radio Science in 2005. In the same year, he won the third best outstanding lecturer at the national level from the Ministry of National Education. Currently, Mr. Gamantio is the IEEE Indonesia Section Vice Chairman. Research interests are radio wave propagation, multi-antenna communication, and radar array processing.
Well, that's another wow achievement, Professor Gamantio. Well,
Thank you.
we will not be able to be there. That is very high. Okay, Professor Gamantio, now coming to your presentation, please make it convenient for 40 minutes.
3 minutes.
Thank you very much. It will start from now. Please.
Okay, thank you. I would like to share my presentation. Okay, can anyone see it?
Yes, sir, clearly.
Very clear.
Okay, thank you. Okay, good morning, good evening, good afternoon for everyone, because I don't know where you come from. Yeah, so probably you come from probably all over the world. So I would like to start my presentation. Earlier, I think we just talked a little bit about rain. Yeah, after the heat, we will have rain. Now we would see if rain events, what I would like to call rain events in Indonesia, could have an impact on millimeter wave propagation. Yeah. So my title today, for my talk today, is studies on millimeter wave propagation in the tropics and current research potential. So I prepare this talk just for the audience of the Isemantic. Let me change the pointer. Yeah. Okay. I'll continue. Okay, so I will talk about the motivation of this talk, and then how the millimeter wave tropical rain-induced attenuation modeling attempts have been done at ITS in my university. And then this will include distribution of rain rate and millimeter wave attenuation, space-time variation of rain attenuation. And then we will talk about how to mitigate the attenuation impact of the rain on millimeter wave radio propagation. And that includes two families of methods. The first one is adaptive transmission, and the other one is joint optimization of radio resources. And then after that, we will arrive at the conclusions, and I will also give some current issues that we still have to solve. Okay, so as the motivation, in the past, there were already some efforts, such as the earlier version of 802.16. So we knew 802.16 by the name of WiMAX, and actually at that time WiMAX was designed to use frequencies below 10 gigahertz, so there would be no significant impact by rain. But in the earlier version, actually there were some proposals to use higher frequencies, more than 10 gigahertz. Also, in the past, we have a system called YPass from Japan, and also LMDS from Europe, and I think also from Canada, which were designed to use millimeter wave as carriers for high capacity access links. Right now, 5G is under deployment in Indonesia, and millimeter wave is one of the carrier wave frequencies to be used for high capacity access and backhaul links. And actually, millimeter waves are expected to be one of the game changers because using millimeter wave, we could have very high capacity because there's a very large bandwidth available, yeah, in that band. So probably I haven't mentioned anywhere here. So millimeter wave is usually used. The term is usually used to refer to the frequencies around 20 to probably 40 gigahertz. Yeah. So those are the frequencies that are commonly referred to. Although lately people are also looking at 60 gigahertz and 80 gigahertz. Yeah. So those are the millimeter waves that we are going to talk about, especially around the 30 gigahertz. And then while 5G is still under deployment, people are already looking at 6G, yeah, sixth generation of communications. And 6G is also envisioned to use new frequency carriers such as the visible light and a terahertz wave. And these are being studied. On the other hand, if we are looking at the climate, yeah, the climate in Indonesia, just as has been mentioned by our moderator, we have of course we have fog, especially in the mountains, on the mountains, but especially we have tropical rain, very heavy rain sometimes, yeah, and there was already some experiment, yeah, employing 28 gigahertz radio waves in Surabaya along a radio link of 5.7 kilometer length, and the attenuation could be as high as 80 dB due to the rain only. Yeah, due to the rain only. So it is quite a high value, yeah, for attenuation, and which means that if we want to make sure that the link, the communication link, the radio link could work well, that means we have to provide very large transmit power, for example, yeah, very large power margin in the link budgets, and that would be very expensive. Yeah? So that's the motivation. Um, Here we would see the impact of tropical rain on radio wave propagation at millimeter wave band and beyond. And beyond means even higher frequencies. That needs to be investigated. And this includes several things here. The short-term and yearly variations, yeah, mean that the rain rate and attenuation should be well modeled statistically, yeah, because rain is also varying with time and also with space. Yeah, so there should be some modeling, which probably later on can be used to devise a technique, yeah, to mitigate any destructive impact of rain attenuation, especially in the tropical regions. Yeah. So this is just an accompanying image, but I would like to show that actually Indonesia, especially the Ministry of Communications and Informatics, have planned to use 26 gigahertz, yeah, for carrier frequency, yeah, in the band that they call high band, yeah, to provide 100 megabit per second user data rate with very low latency, only 1 millisecond, and this is called super data layer. Yeah, so that means we really have to look at the impact of rain on millimeter wave, because otherwise we don't know the impact of rain, and then probably the rain will destroy the performance, yeah, the performance of the radio link at 26 gigahertz that will be used in Indonesia. So this is a kind of history of research on millimeter wave rain attenuation that we have done in ITS. Yeah, about 30 years ago. Yeah, 30 years ago, I was still a student at that time in ITS. There was a simultaneous measurement of rain attenuation. At that time, it's the frequency under observation is in the KU band, which is around 11 or 12 gigahertz, still way beyond below the millimeter wave actually, and also measurement of rain rate, yeah, on satellite to ground channels. And this was collaboration between Eindhoven University of Technology, ITS, and Intelsat. And I think one of the most relevant results of this research with the millimeter wave problem is the 3 years measurement of rainfall rate. So that means we could have quite accurate rainfall rate distribution, which can be used later on modeling the millimeter wave attenuation. In 1999, there was another project, a measurement project for rain attenuation at 30 gigahertz on a terrestrial link, which was also a collaboration between ITS and TU Eindhoven. But at that time, we also worked together with Indosat, and there was an initial indication of the significance, the severity of rain attenuation at millimeter wave band that we cannot ignore. Yeah, and later on around 2006 to 2012, we also did some measurement and modeling of space-time variation of rain attenuation at 30 gigahertz. Yeah, and from that project, we obtained some rain rate distribution. So in addition to the ones that we already get from 1990s, and then also temporal and spatial correlation, which can be used later to devise a space-time model for rain attenuation. And right now we are planning to restart again some investigation on the impact of rain on millimeter wave propagation, especially with the deployment of 5G coming probably this and the coming years. Yeah, so there will be some other things that we should do, and we will discuss that later. I think in 1991, 1993, this is the first collaboration between the Eindhoven ITS and using a satellite from Intel, owned by Intelsat. We have a measurement system over here that includes a beacon receiver from to receive signals from the beacon signals from the Intelsat satellite. And we also have a radiometer to measure the noise, the sky noise, and then rain meter to measure the rainfall rate. And from that measurement, we could see we could have 3 years measurement of rain rate, which can be read here. So, for example, so the 3 years are comprised of 1991, 1992, and 1993. Yeah. So if we see a little bit in detail, yeah, on the rain statistics, we could see that for example, let's say in the third year, yeah, the rain rate could reach 181 millimeter per hour, and which is very high, very heavy rain. Yeah, very heavy rain. Although this could only happen 0.001% probability in a year. So the possibility of this happening is very low, but it could happen. And if it happens, then the attenuation experienced by the millimeter wave could be very high, and then probably even the connection could be broken. Yeah, even for a while, it can decrease the level of service. Yeah, the level of service from the network operator. Yeah. So also another result from that from these measurements is that the ITUR recommendations of rainfall rate distributions turn out to be not actually in line with what we have measured in Surabaya. Yeah. So the conclusion of those that project is that the distribution of rain rate in any region given in the ITUR recommendation is likely not in agreement with the actual distribution measured locally. And I would like to comment that this is actually from the old ITUR recommendation. The later recommendations do not use the regions anymore, but they use contour diagrams covering the whole surface of the Earth, and those contours give us the rain statistics to be used in prediction method that they provide. Yeah. So, but the essence of this finding is that what the ITUR presents in their recommendation is not necessarily in line with what actually happens in our own local region. For example, in let's say around Surabaya, or in the northern part or northeast part of, let's say, of the Java Island, for example. Yeah. So better statistical models should be developed for each local regions, yeah, for use in millimeter wave communication system design. And later on, we could also see that these statistics could be different from one region to another. Yeah, because, for example, okay, Surabaya is quite hot, but if it rains, it pours. Yeah, so we could compare this, for example, to the area of in Nusa Tenggara, perhaps. Yeah, in Lombok, for example, where the climate is more arid. Yeah, more dry. Yeah, so there in Lombok, for example, the rain statistic would be different from what we have in Surabaya or Jakarta or Semarang. Yeah. Okay, so the second project is also another collaboration with Endofan, but now we also collaborated with Indosat, and the measurement itself also happens in ITS, and we actually built a radio link, 28 gigahertz radio link between the campus of ITS with the office, yeah, and the rooftop of the office building of Indosat in Surabaya. And the link actually spans about 5.9 kilometer. And from the measurement that we obtained at that time, the highest attenuation that was measured could reach up to 80 dB, which is a very large number. Yeah. And then the next project is actually the longer one, the longest one probably. So we would like to see a small the variation of the rain attenuation, yeah, attenuation induced by rain in a smaller area, because we know that in the future, this is from 2006 to 2012. So at that time, there was not yet any coordinated effort to develop 5G. Yeah, but at the time we already had a vision that in the future we would have millimeter wave communications in which the cell size, the cell size, the network cell size would be very small. Yeah, so here we have installed a number of rain gauges, yeah, in the campus of ITS. Yeah, so we have a simultaneous measurement using a disdrometer, which can be used to measure the rain rate using an apparatus that has a laser transmitter and a detector. Yeah, and then we had a set of rain gauges, and also we had a radio link, 29 gigahertz radio link, spanning a distance of 1 kilometer. So this is a kind of short distance that at the time we thought it could represent a small cell, yeah, as a base station with only 1 kilometer kilometer coverage radius. Yeah. So we obtained rainfall rate distribution from this measurement, also rain attenuation distribution, which we obtained using the technique called synthetic storm technique, yeah, SST. We could also obtain time-space variation of rain rate and specific attenuation. Specific attenuation here is given in dB per kilometer. Yeah, dB per kilometer. So it's like the attenuation over a unit of distance. In this case, 1 kilometer, yeah, and this is at 29 gigahertz. These results are important for the purpose of evaluation of various proposals of attenuation mitigation schemes. Yeah, so if we want to make sure that our mitigation scheme, our schemes that we propose to mitigate the effect of rain attenuation on millimeter wave, then we have to also have a method to simulate the mitigation schemes, yeah, under computer generated rain events, which should be varying not just with time but also with space, with locations, yeah. So this is the map, yeah. We put the stars here represent the locations of the rain gauge, and then the dashed line here represent the radio link, yeah. Okay, so the measurement results, we could see that, there are two main results actually. The rain in Surabaya, just like in Singapore, tends to have more large raindrops, yeah, more large raindrops. So the diameter of the raindrops, yeah, tend to be larger, yeah, than the model proposed, an old model, yeah, proposed by Marshall and Palmer, based on their measurements in North America. Now we have to be careful here because North America have a different characteristics of rain, yeah, because okay, so North America is quite far from the tropical region, right? It's even probably closer to the pole, to the North Pole, yeah. So the rain statistics would be would be lighter, yeah, than what we have in Indonesia, yeah, in tropical regions, yeah. So this means that the model, the rain model, the rain statistic that are actually the process, the method to predict the rain rate and attenuation used or proposed for applications in North America could be different from the one that should be used in Indonesia, for example. Yeah. So rain events in Surabaya also show greater temporal correlation than those reported from Barcelona, from Europe. Yeah. So here we also see another thing, another important thing that states that the time varying rain could have in Indonesia could have higher correlation, yeah, from one time to, let's say, 1 second or 1 minute after, yeah, compared to the rain that happens in Europe, in Barcelona, for example. Yeah, so these two are two different characteristics that we have for rain, yeah, in tropical regions. Yeah. So more findings, log normal distribution, which is usually commonly used, yeah, to model non-tropical rain attenuation. The highlight here is the non-tropical, yeah, because this is proposed by researchers in Europe, North America, or probably Japan, Korea, and so on, yeah. And this distribution is not suitable for tropical rain attenuation. And later on, actually, this should read ARMA, ARMA, and ARIMA. Yeah? There are two models that we proposed to generate time series of rain attenuation on a short link, or actually on multiple short links. Yeah. I give you some references here. If you want to ask more about this, you can ask me later. Yeah. So here we could see that even the orientation of the links could result in different distribution of attenuation. Yeah, so it's amazing. The result is so enlightening. Yeah, so it gives us more knowledge about the characteristics of rain that happens in Indonesia, which could impact the millimeter wave links when those links are going to be built in Indonesia. So the mitigation schemes that we propose comprises of two families of techniques. The first one involves the radio access techniques, which includes adaptive transmission, or actually adaptive, we call adaptive transmission because not just the power, but also the modulation scheme is also adaptive. And then cell site diversity and cell area segmentation. Yeah? And another family of schemes is joint optimization of radio resources. So this is what we propose. Yeah. So our earlier studies on cellular configurations with a square cell. So here we have 4 base station. Yeah. Each base station is positioned in the corner of this square. Yeah. So this subsquare, the smaller square here, is normally belonging to this base station. This small square here is normally belonging in the coverage area of this base station, and so on. Yeah. So the problem is that, for example, if okay, there is a user here. Yeah, a user here. Let's say a fixed user. Yeah, user residing in a home, and that he has an equipment for communicating with the base stations. Yeah. So if there is a user here, and then normally he will be served by this base station, but then there is rain here. Yeah, rain is happening here. Then what should we do? Yeah? What should we do with this user? Because this user is having a risk of losing connection. Yeah. So um, we studied on how to serve that user properly. Yeah. So the targeted users here are those located near the cell edge. So the people residing here, the users residing here, are having the greatest risk of losing the connection when there is rain. Yeah. So the targeted performance is the achievement of an availability. Yeah. Where availability means actually the percentage of time where the connection is working properly. Yeah. Not disconnected. Yeah. So the achievement of an availability value pre-specified for a given maximum probability of bit error. Yeah, so the quality, yeah, the quality of the connection becomes the performance indicator. Yeah, becomes the definition or the threshold. Yeah, for the availability. Yeah, if the probability of bit error is too high, then we say that the channel is or the link actually is not available. Yeah, because there are too many errors. Yeah, uh, experienced by this user. So there are several possible methods that can be used. That is by adaptively adjusting transmit power, modulation level, or if you want to get more sophisticated, okay, we can use a channel coding scheme that is also adaptive, or selecting signal with the best quality out of the 2 hubs, or even combination of them. Yeah, combination of these 4 schemes. Yeah. So this is the table shows an example of how to achieve that. Yeah. So the further effort that we did already we proposed already is to try to segment the square area of the base station coverage area and apply different adaptive techniques in different segments. So we know that the people who will have the greatest risk of losing connection is the ones near the borders, the cell borders. That means we will give the most sophisticated scheme to those people. Yeah, over there. Yeah. So that why? Because they have the greatest risk. So we should prioritize them more than the one that is closer to the base station, because the closer a user to the base station, then the rain attenuation that they experience would be not as high as those near the cell borders. Yeah. So here we arrange a table. Yeah. And then this is for adaptive modulation. Yeah. Actually, not just the modulation, but also the codes. Yeah, because we have some channel codes integrated to the transmission system. So if the SNR, the signal to noise power ratio, is too small, then okay, there's no transmission. So in this case, no transmissions means the link is not available, which is actually bad. Yeah, which is a bad thing. Yeah. So that's why we put the signal to noise ratio, the threshold. Yeah, the threshold. Yeah, quite low. Yeah, only 1.18 decibel. Yeah. Otherwise, the link should be able to be served. Yeah, the link should be served by the base station. In order to be served, we apply adaptive modulation here. So for the SNR just above the no transmission situation, we should use a lower level modulation, for example, and much powerful coding schemes, yeah, for example, and so on, yeah. So the larger the signal to noise power ratio experienced by the user, we could increase the modulation level, yeah. For example, here 64 QAM, even probably to 256 QAM that are currently also used by the OFDM waveform in 5G actually. Yeah? So this is the scheme in general, and then the area segmentation. Yeah, I already said before that another additional strategy is to divide the coverage area into segments. Yeah, so people users, yeah, in segment number 2 here in the middle should be given more sophisticated transmission schemes. Yeah, that includes, for example, in this case, that includes, let's say, a fixed. Sorry. Um, we should go back here. That includes, for example, this one. Yeah, 16 QM with Ritz-Solomon codes and combined with convolutional codes and so on. Yeah, but for the people closer to here. Okay, so segment 1 here doesn't need. Segment 1 here is for users closer to the base station. Yeah, so for those in the range of, let's say, 1 kilometer from the base station, what they need is just a fixed 64 QM. Yeah, but for users in the region number 2 here in the middle, they should use adaptive modulation. Yeah, so this one, so only the first two um, rows, yeah, in this table. Yeah. The second family of the technique is by doing a joint optimization of radio resources, and this include, for example, here in this case, joint subcarrier and power allocation. So with the 5G schemes that are being deployed now, we could actually make use of the subcarrier aggregation feature, yeah, that they have, yeah, to do this actually. Yeah. So joint optimization can be done, yeah, on both subcarrier and power. So these optimizations are done simultaneously, considering two parameters. Yeah. So actually, my student at that time simulated this. Yeah. He started with single cell, radius 2 kilometer with 8,000 subcarriers, only for users for now, and the rain attenuation on each link is generated by synthetic storm technique using the rain rate distribution that we have measured before. So, for example, here the cell is pictured here as a circular cell. Yeah, there are 4 users separated in the angular domain, yeah, by some angles. Yeah, so different angles means probably different rain attenuation. Yeah, because there is space, the variation in space, yeah, of the rain attenuation. The results are these. So several approaches were evaluated. Of course, we have JSPA, joint subcarrier power, before, but we also have joint frequency power allocation. The difference is that in JSPA, we are playing with or we are playing at the level of subcarriers in the same frequency band, but in JFPA we are playing with different frequency bands. And we compared these two proposed methods with the dynamic subcarrier allocation and adaptive power allocation that actually only, let's say, only optimize one parameter. Yeah. So unlike these last two, which optimize two parameters jointly. Yeah. The finding is that the GSPA, and GFPA are here, yeah, showing higher probabilities of high utilization. So which also means high availability, yeah, compared to the FSA and the SA. So this could be done. Yeah, I think even in 5G, this also could be applied. Yeah. So the conclusions of that study is that knowledge of distribution and space-time variation of rain rate and attenuation is very important in developing mitigation schemes of the impact of attenuation on millimeter wave propagation. And there are two different families of methods to mitigate the impact of tropical rain attenuation. And these are adaptive transmission with area segmentation and joint optimization of radio resources. These schemes are potentially realizable with the subcarrier aggregation scheme and also with the software-defined network technology currently used in 5G networks. Yeah, they should read 5G. Yeah? 5G networks. I arrive at the probably closing slides. Yeah? The current issues. Yeah, we now have 5G deployment process in Indonesia. Different regions. We know already that different regions have different rainfall rate and attenuation distributions. That means also different power budgets for different regions if we want to deploy 5G networks in those regions. And we also know variations among regions in Indonesia, just as I said before. For example, in rainy Bogor, for example, yeah, and other areas with heavy rain rates, yeah, they have heavy rain rates, yeah. But on the other hand, in Nusa Tenggara Islands, we have arid areas, yeah, with lighter rain rates, yeah. And aside from those two, we also have mountainous area with orographic type of rain. So this is I think another type of rain that comes that happens in mountainous areas, yeah, where the cloud is going up to the peak of the mountain and then becomes falling as falling rain, yeah, fall as a falling rain. And the statistics could be different, yeah. So local rainfall rate distributions are potentially available from local weather offices. Yeah, so I will have to check this. Yeah, because as far as I know, some local weather offices are still using cumulative rain meters, not the rain meters that can measure short time, for example, 1 minute rain rate, for example. Yeah. So if these are available, then that would be a good opportunity for us to actually prepare some knowledge, yeah, and give it to the industries, yeah, to the telco industries, to provide them with the correct or the proper power budgets, yeah, for 5G deployment in various areas in Indonesia. Also, space-time time series, yeah, of rain space-time series, yeah, of rain attenuation can adopt the ARMA or ARIMA, the ARMA and the ARIMA models, or generated using the synthetic storm method that we have already used before.
Yeah.
This is probably the last two slides. Yeah. In ITS now we have the 5G Experience Center, which was launched just 2 days ago. Yeah, which is a collaboration between ITS, Nokia Indonesia, and Indosat. Yeah. And this is also funded by the industries and as well as the Daireka program from the Ministry of Education. And the most important thing is that we already plan to do some experiments, yeah, with millimeter wave transmission for 5G services as a part of this program. Yeah, so this would be a very good opportunity to learn more about the rain characteristics with regards to the 5G deployment. Also, beyond 5G, this is also important because, for example, 6G is already looking at visible light communication and terahertz communication. Uh, Actually, in fact, we already looked at free space optics, and we tried to test, yeah, to evaluate the use of cell site diversity, yeah, to improve the performance of free space optics, yeah. And this is already from 2012, yeah, so it's quite long ago. So the bottom line, I guess, here is that Indonesian researchers should work together to develop technologies and strategies in mitigating the tropical rain impact on these new carrier waves, so that in the future we could actually maximally use um, the availability, or the presence of millimeter wave radio links that can provide us with a very high capacity for broadband communications. So that's, I think, the last slide. So thank you, terima kasih. Please, Pak Moderator and Bu Moderator, to continue. Thank you very much.
Yes, sir.
Okay, thank you very much, Professor Kamantia. Well, mitigating rain impact. This is really mind intriguing. Something. Well, this is something different. Mitigating rain impact. Yeah, with the waves. Considering the radio waves. Well, this is something, and very very interesting. We're coming to the session. We still have 15 minutes, Professor.
Yep.
We have somebody here. This is, well, we translate into English from Mr. Novala Raditya Tama. We are talking about the use of 5G. Is it really of high consumption of battery?
Pardon?
Is there something the relation between the use of 5G and the high battery consumption?
Okay, battery lifetime and so on. Yeah.
Yes, that's right.
Yes. Yeah. If you are talking about the user terminals, handphone, for example, with a battery with a limited lifetime, a limited power consumption, power supply, for example, yeah, then yes. If, for example, there is rain and the user terminal is working at millimeter wave, or actually at that time are using millimeter wave link to be able to obtain high capacity information, yeah, from let's say from the network, yeah, then yes, there will be dilemmas here, because okay, for the base station, probably there is no limitation on the power, yeah. Although actually 5G tries to limit power consumptions at the base station site, yeah. That's why now they are using, for example, multi antenna technologies, yeah. In millimeter wave band, for example, in 30 gigahertz, for example, the wavelength is just 1 centimeter, so that the size of an antenna at millimeter wave at 30 gigahertz, for example, is approximately just 1 centimeter, so that they can build an array, an antenna array, yeah, with many elements, yeah, many elements, but still maintaining a very small size, because the size of the antenna, each antenna element is still very small. Yeah, with these many elements, they can increase the gain of the antenna, so that they do not need to increase the transmitted power itself. That's from the base station point of view. But now, if we are talking about handphone, for example, yeah, or other small terminals, then the power consumption is limited, yeah, and we could not put there is a limited space to put antennas with higher gain, yeah. So if probably we are using laptop, it's probably a little bit different story, yeah. But handphone is, it's very small and so on, yeah. We could probably put, let's say, probably 10 elements of 10 elements of antennas, yeah, over there, and that could only increase the power by let's say several times, yeah, considering other things that could reduce the efficiency of the transmission. Um, that could be done, but if the rain is very heavy, yeah, sometimes it is very destructive, yeah, and even if using the higher gain of antenna, yeah, at the handphone, we could not overcome the impact of rain attenuation. Yes, so I think in this case, um, the uplink, yeah, the one from from the handphone to the base station should use lower band, probably, yeah. But we still have to learn more about this, yeah. Probably we could find a strategy, a technique, yeah, that has not been thought of before, yeah, that could improve the situation. So I guess that's my question, my answer.
Yeah, so there is some significance, yeah. And then we were talking about the 5G support. Is it really significant to the network performance, especially for the gamers? For the gamers, they need support by 5G for the networking performance. Is the support by 5G significant?
Oh yeah. Okay, so we are talking about gamers, yeah, gaming, yeah. Yeah. Okay. Yeah, I think gaming will benefit from the use of 5G because especially online gaming, of course, yeah. Because in gaming, the response given by a player at a location should be observed immediately by another player in another location. Yeah, but in this case, I think the most relevant or the most important feature of 5G that takes the most decisive role in this case is not the millimeter wave, but the low latency feature. Yeah, the low latency feature. So we know that there are three, uh, let's say three types of applications. Yeah, offered by 5G, and one of them is the ultra reliable low latency communications. So the low latency, the low delay, yeah, the low time delay is the one that will be more important for applications like gaming, and also for applications like autonomous vehicle, for example, yeah, because the information should be sent immediately, yeah, and the electric vehicle should also respond. The autonomous vehicle should also respond immediately, yeah. The response should be immediately received, or, yeah, by the other party, for example, yeah. So in this case, those are the features that are important, yeah, for the autonomous vehicle and also for the gamers, yeah.
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 Thank you very much. Thank you, Mr. Naufal Raditya for the question. Now we coming to somebody else. This is again Johnny Aritonang. From the study of millimeter wave propagation in the topics by the speaker, what theories are the references? Can this wave predict rain in a tropical area? What about non-tropical areas? Thank you.
Okay, so okay, thank you, Pak. Okay, so the purpose of the study of course is not to predict if rain would happen. No, yeah, no. But what we would like to do is actually to mitigate if the rain has already been happening now, is happening now, yeah. We would like to propose a mitigation technique, yeah, to propose a technique to mitigate or actually to reduce, yeah, the impact of the attenuation, yeah, induced or created by the rain, yeah. So we are not going to predict rain or something like that, yeah. And you're asking about the theories. Okay, actually the study itself, there are several studies that I actually had done in the past. For example, you could look at my papers, perhaps. Although I didn't list it in as listed my papers as references here. There is one paper talking about how, actually two papers perhaps, yeah, talking about how the raindrops, the falling raindrops, could affect the electromagnetic wave that comes into the space, the 3D volume, the volume space, yeah, uh, that have falling raindrops in it, yeah. So there are some mathematical derivation using computational electromagnetics, actually not done by me but by my colleagues, yeah, that says that like if the electromagnetic wave at the very high frequencies with wavelength in the order of the size of the raindrops, then there would be some energies that will be scattered, yeah. Some are scattered to another direction, for example, but there will also be some energy that is scattered on the same direction, yeah. And this scattered wave on the same direction, we should call it forward scattering, will be received with lower power by a receiver, for example, yeah. So probably you're also asking about non-tropical areas. In fact, I also did my doctoral study studying about the millimeter wave attenuation in North America. So I already did that, and you might expect that the significance of rain attenuation there is not as high as what we will have here in Indonesia. So I think that's my answer and my comment.
Okay, thank you very much, Professor. Now we have something else about myth or fact.
Oh, okay.
This is about myth or fact. Is it true that the 5G network is not optimal to penetrate barriers such as buildings, walls, concrete, trees, and other barriers? It is true. Is it true or not, Professor?
Okay, so the question is 5G in general. If the question is 5G in general, then we could have different answers for different frequency bands. Yeah. If you're talking about earlier, I show you a diagram showing the possible frequencies that will be used for 5G in Indonesia, issued by the Ministry of Kominfo. Yeah. Of course, if you're using, let's say, 700 megahertz, then it's really can go anywhere, even indoors. Yeah, of course. But of course, the waves that we receive indoors will come from different propagation paths, come from different routes. For example, there will be one path that is reflection path from the wall of our neighbor's home, for example, and then there is another path coming from another neighbor's home from the other side, perhaps. Yeah. So everything will come inside and mixed up, yeah, into a signal that could be probably could be having a high level, or sometimes if the signals coming from different paths have a phase, yeah, an opposite phases, yeah, then those waves could distract one another, so that the level of the signal that we receive could be low. Yeah. But for 700 megahertz, there should be no significant problem. Yeah. But for the other band is the one that we call sub 6, which is around 2 or 3 gigahertz. We already have experience with 2 or 3 gigahertz. For example, now for our Wi-Fi, our Wi-Fi now, the access point for our Wi-Fi works at 2.4 gigahertz. So the behavior of the radio waves would be the same, yeah, as the one used in 5G for around 2 or 3 gigahertz. Yeah. The new thing that we will experience is the millimeter wave, yeah, the 26 gigahertz. The 26 gigahertz cannot, I would say almost certainly, yeah, cannot penetrate the wall. Yeah, cannot penetrate the wall. The diffraction loss is very high. Yeah. So if you are really in a room, yeah, with walls, yeah, brick walls, for example, then what you have is a millimeter wave access point outside. Then there is the high probability that the millimeter wave could not reach you inside the room. Inside the room, yeah. So because it cannot penetrate the brick wall, for example. Yeah. Okay.
Thank you. Thank you,
Welcome.
Professor. So we are talking about the other means, the other tool, the other apparatus. Now, the questions coming are about the 5G and fiber optics.
Yeah.
What is 5G really better than fiber optics? Or if not, is there any theory to make them equal?
We are talking about, okay,
5G and fiber optics.
that's because I think the answer, yeah, the answer does not only depend on the nature of the radio waves used in 5G and the optical waves used in fiber optics. Yeah. As I said before, the low latency of 5G happens not because of the use of the millimeter wave, but it's the result of the use of the edge computing technology. Yeah, so that's why the surface the users could get the surface that he or she wants more immediately. Yeah, when compared to, for example, the previous technology that doesn't make use of the edge computing technology. So it's not about the wave the wave frequency that are used, yeah, but more about how the technology is used in the network. Yeah, in this case, the edge computing. That's my answer, perhaps.
Yeah. Well, thank you very much for the explanation, Professor, and thank you very much for the question, Mr. Kemas Amando Ayub. Well, I think time is flying, Professor. Well, this is already 1 hour, and you have given us very what is it? Mind intriguing, I think. Mind intriguing material of presentation, and this is something new, and also this is also part of the development of our beloved country, Indonesia, I think. And your contribution is something. Well, ladies and gentlemen, the audience, before we close this session, let's give a big hand to Professor Gamantio. Thank you very much. Thank you very much. Thank you very much. Bye-bye, to see you again next time.
See you again.
Hope to see you. Bye-bye, Professor. Assalamualaikum warahmatullahi wabarakatuh. Yes.
The last one, sir.
Well, time has flown very fast. Now, ladies and gentlemen, I hope you still staying to the end of the session. You still alert and attentive to this presentation. Now we're coming to the last but not least presenter from our home university, from our beloved Dinus University. We are coming to Dr. Heru Agus Santoso. We'd like to make some greeting to the gentleman. Hello.
Hello.
Hello, Doctor.
Sound is good. Hello.
Hello. Oh, you look great. You look great, but
okay, thank you.
Yeah. Okay. This
sound
is
good, right?
Smiling face doctor. Well, that's very good. Yeah. Okay, Dr. Heru Agus Santoso. Before your presentation, I'd like to say something. That this is audience. This is Dr. Heru Agus Santoso. Yes, very young professional, yeah, and very potential from our country, from Universitas Dinus. He is an expert in something connecting to robots. We are talking about robots today. He is presenting to us a topic with the title Ontological Knowledge Representation for smart robot. So KR here is very noted in the world, and he is talking about this KR ontologically for the smart robot. Before that, we're going to show you to present to you some introduction about our expert. Please, Ms. Titin.
Okay, good morning, Mr. Heru Agus Santoso. I would like to read some brief bio of yours. Received PhD degree in Multimedia University, Malaysia. Mr. Heru Agus Santoso, also an active writer and peer reviewer of the International Journal of Knowledge-Based System, Elsevier, which has impact factor of 5. Current position, Dean Faculty of Engineering at Dinus University. Being able to get several research achievement and academic position, he developed research environment between student and lecturer in IoT and chatbot lab. Dinus Automatic System of Hydroponic Based IoT, Dashi, one of his research to fulfill Industry 4.0 in Indonesia, has anticipating failure in planting technique using water or hydroponics. Through this application, farmers can monitor their crops on various sites, such as humidity, room temperature, water pH content, water density, and even being able to automatically add water. If the water in the reservoir is reduced or below a predetermined limit. And research interest of Mr. Heru Agus is ontology, semantic web, information retrieval, and text mining.
Wow, it makes me speechless. Yeah, Ms. Titin. Well, okay, Dr. Heru Agus Santoso, now it's time for you to present your thoughts, so ideas about this robot, this KR, yeah, knowledge representation. Please make it convenient for 40 minutes. 40 minutes, please. And it will start from now. Thank you.
Okay, thank you for the nice introduction, Prof. Yu and Putitin. I'm going to share my presentation. Only has all participants. Can we share my presentation?
Yes.
I want to share my presentation, but cannot.
Yeah.
Sharing. Maybe the
okay. Please wait a minute. Yeah, maybe there is some technical problem here. Okay, just wait a minute. Maybe would like to sing something, make a poem.
Yes. Actually, before this time, I tried to.
Oh yeah. Permission is already granted. Permission is already granted. Okay.
Really?
Does it work?
Only host. I am not the host actually. How come I cannot share my presentation?
Okay, please wait a minute.
Maybe I can. Okay. Wait.
Okay, while waiting for the technical problems, I'd like maybe you want to say something about what you're going to present today.
Yes, actually, this is part of my study, and this Isemantic 2021 theme is quite connected to us since in this pandemic period, we can really grab a lot of opportunity, especially the government funding for our faculty. So the theme is nice, very nice, and connected to ours. And what we are going to present is actually part of my research funded by the government. We got for about 2.1 million.
Wow.
And but only small chunk of the money going to the robot. Actually, we have several research funded by government. How come I cannot share the?
Not yet, sir. We're still working on it. Yeah. Okay. We're talking about the ontology, especially about the robot itself. Are you also interested in the future talking about the methods and also the significance of the robots in the future?
Yes, of course. Maybe someone already know that for about 5 months ago, I moved to faculty engineering, and we have to really shoot with the situation, especially for the research topic in faculty engineering. Before that, I was at faculty of computer science, and we can really apply the method, the approach in the computer science field to really fit the research in the computer and engineering, including robot. That's what we think, and I think I'm blessed because we can join the new field, but still really connected to my research interest. And robot become my next project because there are so many opportunities, especially in this pandemic period, since, for instance, the government need safer services because of the spreading of viruses, and then robot become the solution.
I see. Yeah. Okay, Dr. Heru, could you please try to share again the material?
Maybe I share with someone.
Okay.
And then
no, you try again.
Cannot. I don't know why.
Still not operable.
Yes. All who can share only host. All participants. Yes, I can share the. I don't know why. This morning I tried, and then it really worked. But
So we are still working on it. Yeah.
I don't know. So I will share to one of you, and then you can.
And maybe it will take time. Maybe you can present by what is it? Telling.
Okay.
It
already worked.
on the
Okay.
presentation. Yeah.
Okay, already worked.
Okay.
Thank you.
Alhamdulillah.
Alhamdulillah.
Finally. Yeah.
Yes.
Yeah. It is something of a test for you.
Yes.
For us.
Okay.
For us. Yeah. It's very interesting picture. Okay.
This is the robot we developed. We are developing right now for the Semarang city government, and the last is for the industry in the Klaten, for the government industry. And what we are going to cover in this presentation is what is knowledge representation and ontology is, and the standard from IEEE for ontology and for robot and automation. And we are going to discuss related work and discuss about our project. And then before we go to the how to represent the ontology for robotic, and then we have to make it clear what is actually the knowledge, right? So let's try. Maybe someone already presented to someone else and then explain what is knowledge, but we have to make it clear right now what is actually the knowledge. As you can see in the slide, we have set of truth, set of belief, and intersection between truth and belief. That is true belief.
Suara saya sudah nggak kedengeran kan?
What is out there in the world are the so-called set of the truth, right? The set of the properties that according with fact is the truth. But not all the truth we know, right? And then we come up with the belief. Belief is what we think in our head and what we think that is true. And among belief and truth, we have true belief. And everything we can call true belief actually not really become knowledge unless we justify it, right? So knowledge is justified through belief. So using the formal definition, we can say that someone knows that Q is part of the knowledge if and only if Q is true, S believe that Q is true, and S is justified in believing that Q is true, right? And then to represent the knowledge in the formal language, we need ontology. What makes formal important? What makes formal language become very important for representing the knowledge within in the robot domain is how can knowledge become understandable for machine and for human. As we realize that robot currently can communicate with a lot of devices like IoT, for instance, and then communicate with different type of robot, for instance. Moreover, currently robot can communicate with human and robot interaction. So formal language become very crucial in this situation. Okay, let me get closer. What is actually the knowledge representation is? In our previous slide, we just explained that knowledge is justified subset of all true belief, and knowledge representation is a way of explicitly represent knowledge for specific domain. And since AI become more influence in our daily activity, knowledge representation can ambiguously capture the semantic of domain represented by set of concept, properties, and relationship. Right? Maybe someone still confused about concept, properties, and relationship. If we see it in the object-oriented paradigm, so concept closely related to the class, and properties how to characterize the class and the concept itself. Actually, just like attribute, maybe data type, something like that. And then relationship is how concept can relate to another concept. Example of concept, for instance, like fruit, right? Fruit is concept. And then man is concept. And instantiation of the concept is, for instance, we can say nanas, pineapple is an instantiation of the concept. So by using knowledge representation, machine hopefully cannot only able to read, but can understand the meaning of the knowledge itself. As we can see in the daily activity, computer can read HTML document, but actually computer cannot understand the meaning of the HTML document itself. That's why knowledge representation using formal language will explain the meaning of the knowledge. And we need a formal language. In our project, we use web ontology language standardized by AWWC. This is an example of ontology. We get closer to the definition of the ontology. For example, given the information, the price of Apple has increased 25% during COVID-19 pandemic. In our mind, we can easily understand the meaning of the sentence, but for computer, still not easily understand. What is actually Apple? Is that fruit, or maybe is that smartphone, or maybe laptop? That's why in the figure we can see the structure of knowledge we can represent using ontology, and also we can really precise understand the meaning of the term in the sentence. For instance, we can understand the apple here is discussing about fruit, but we need to really focus on the specific domain we are talking about. That is about fruit and related physical object, for instance, vegetable and so forth. And this is actually the meaning of the ontology: explicit and formal specification of shared conceptualization. Let's discuss each term explicit in the definition. A conceptualization is an abstract model. We need the specific domain to identify relevant concept and their relation. And explicit mean the semantic, the meaning of the concept must be explicitly defined using formal language, right? And then formal need mathematical logic language so that machine can understand, can interpret the meaning correctly, not ambiguously. And then share, we have to share consensus about the terminology in the ontology, and the main task when we develop ontology is try to reuse the existing ontology in the related domain. So we can reuse instead of creating or maybe developing from the scratch by ourselves. And then we can save our time also, and then we share consensus about the ontology itself. So this is a simple definition about the ontology. Ontology is defined as 7 tuple: C, R, A, R, L, and AX, and so forth. You can define ontology by your own need and your own domain. But for the common definition, the ontology must be contain concept, relationship, and also axiom, because 3 main part of the ontology is concept, relationship, and axiom. And as you can see in here, once we knowledge represented using ontology, we can also say that kind of representation as a knowledge base, right? Knowledge base consists of 2 parts. They are TBOC. TBOC is terminological knowledge, like we discussed about in the database designing. We can say that this is the database schema, or maybe the structure of the terminological knowledge. And then in the right side, in the blue color, we can say assertional knowledge, or ABOX. That is instantiation of the class. For instance, carbon dioxide is a instance from the class, and you can see in here carbon dioxide is a greenhouse gas. Based on this knowledge base, so we can identify the membership of the class within the knowledge base. And the reason why we use ontology for our research is because of IEEE standard for robotic and automation already established. And we can see in here IEEE STD 1872 trademark 2015 provide standard ontology for robotic and automation. This ontology taken actually from the sumo, the most common concept in the ontology, and then IEEE standard for robotic and automation provide the most general concept, relation, and axiom for robotic and automation development models. And this standard included reference for knowledge, representation, and reasoning in this field as a formal vocabulary for communicating among robot, among devices, and also human and robot interaction. So this is the IEEE STD 1872 trademark, consists of 4 sub-ontology: CORA, core ontology for robotic and automation, and then extension of the CORA, corrects, position, and air part. And we can use those ontology as the most common term used in our project. And actually IEEE STD 1872 is taken from suggested upper merge ontology, or SUMO. So this is we talk about our current project. As we have discussed before, we have explained it before. We developed a robot for the government of Semarang and for industry in Klaten, and the robot can interact via voice command. If time is available, we can demonstrate how the robot work using simulation, and then the speed of robot should the speed of the applicant walking speed. So once the people work very slowly and robot just follow suit the speed of the applicant, and this robot will be applied in the mall pelayanan terpadu. The mall pelayanan terpadu is the mall for integrated services in the government of Semarang City. How the robot is work? Actually, firstly, they need to greet the applicant, and then try to assist which which services they need to solve in the government services mall. Firstly, the applicant takes the number of the queue, and then followed by the activation of the robot by taking RFID card. Once the RFID card taken by the applicant, and then robot will be activated, and then robot greet the applicant by saying "Selamat datang di Mall Layanan Terpadu," and so forth. And then after the applicant answer the question from the robot working toward, followed by the applicant to the counter of the services. And the speed of robot depend on the speed of the applicant while walking toward to the counter. So this is the related work, quite new actually in this field. As we can see in here, the most similar to our work is number 8, RB, Ontology-Based Knowledge Model for Human Robot Interactive Services 2020, actually still quite new, the research. And also we can see in here, Sabot also closely related to our project high-level smart decision making of robot based on an ontology in search and rescue scenario number 5 and so forth. In their work, there are several tools used in the project. For instance, NoRock using OWL web ontology language standardized by WWC, and also using SWI Prolog. And then you can see in here there are some different tools also. In the Sabot, they use OWL SWRL, semantic web rule language. Sabot here. We plan to use the semantic web rule language for our project, and also Sparkle. Sparkle is query for graph database, so we can integrate data from different resources. This is our schema of our proposed schema of the project. As you can see here in the screen, there are knowledge base consists of TBOK and ABOK. TBOK consists of schema of the knowledge base. We can organize to identify all aspects of the robot activities, robot environment, and robot task or assignment. And then ABOK is the instance of classes exist in the knowledge base. By knowledge base, we can also extract the rule using semantic web rule language. And once the robot need to perform the task, and then the parser and reasoner proceed the task, and planner management using ROS, robotic operating system, will manage and then execute. And this is our approach. Ontology editor, we use Prodigy from Prodigy Stanford.edu. Language, we use Resource Description Framework Schema, RDFS, and OWL. Actually, RDFS is subset of OWL, Web Ontology Language, since the expressivity of the RDFS is part of the expressivity of OWL. And then query, we use semantic web rule language to integrate references rule into ontology. In our project, there are 3 sub-ontology we develop, we model. They are structure, environment, and assignment ontology. And as you can see in here, the structure ontology consists of 3 main subclasses relation. They are robot type, hardware, and software. Each of the class has to describe the properties, the characteristic of the classes, and then we can relate to the instance can be member of the class. For instance, for robot type, we have three type actually: service robot, transportation robot, and the last one is actually what we are discussing right now. That is companion, accompany robot. Accompany robot means the applicant accompanied by a robot to get appropriate service. And then hardware perception devices like camera, line sensor, and then also we identify navigation devices like rotary encoder, accelerometer, gyroscope, and so forth. And Also, we have to identify the base devices like motor, wheel, and battery. Okay, so by developing model for robotic domain for smart robot, actually we can in detail describe where is the capability of the robot will be related to the need of the government. For instance, in here we extract the knowledge from the ontology by stating several axioms. In here, for instance, location point is an environment. The axiom number 1 states that location point is an environment. And the second axiom in here, robot disjoint with obstacle. This is the expression of disjointness. And then in the last two axiom in here, robotic is environment. Environment is robotic environment. In the last two axiom, we actually state the equivalencies, the sameness of the entity among robotic environment and environment. So we use the same function about robotic environment and environment, because this is the two axiom state there are the equivalencies among those class. And also we identify aspect for better utilizing of the knowledge base by providing hierarchical structure to represent assignment by providing sub-ontology, for instance, monitoring task, mapping, chart assignment, and company. And today, actually, we discuss on this specific part, that is a company. How to make knowledge base provide the company aspect while can be utilized by the robot. And for assignment modeling, for instance, in here, we define as a 5 tuple, right? For instance, assignment modeling is a company. A company is assignment modeling for the robot. The company is method actually consists of several atomic activity. We model with 5 tuple, consists of name, parameter, entity, set of entities, and also the status, whether done, still on, or maybe postponed, or maybe need to be continued. And then example of the atomic assignment extracted from the company, we can have atomic assignment. For instance, in the greeting interaction is part of the assignment modeling, and also ready, sound, voice recognition, and so on. So based on the company activity, we can extract several atomic action, like we just explained it before: greeting interaction, keep distance, navigation, arrive interaction, and so forth. So that is actually the whole design of our company robot, and after developing the model, the knowledge base, we need to validate the inconsistency and several checking. For instance, validation of TPOC and APOC after knowledge-based development, because we intend to develop the feature of the robot not in the fixed model, but after the need is after the need is need to be applied in the robot, and then we can extend our functionality. So once we extend the knowledge base, we need to validate the knowledge base using validation and inconsistency checking, and then also TPOC and APOC consistency checking. The tool we use is reasoner like Hermi and Pele. We can check the incoherency in the TPOC. For instance, we provide example of definition. Given T as the T-box of ontology, T is incoherent if there is exists an unsatisfiable concept in the T-box. So maybe it will make the T-box is inconsistency because this is there is unsatisfiable concept in our knowledge base because of the development of new features of the robot, or maybe the modification of the existing knowledge base for robot improvement. So I think enough for all the explanation from my side, and just for information, this study consists of several lecturer and student. My name is Heru, and Pak Pulung, Pak Ari, Pak Zainal Arifin, Pak Aris Jihan, Pak Helmi, Pak Arga, and Pak Alfir is part of our member. So enough from my side. Pak Yumanto, Bu Titin.
Yes.
Thank you.
Okay, thank you very much, Professor Heru. You're talking about the KR and robots. Yeah, there has been some kind of excitement and pride, but also there has been some fear. Some fear, yeah. Fear. This is a question from Ari Wibowo for the first. Somebody is talking about if robots become the solution to support work in a company, does it reduce the employment in Indonesia? And what is the solution? This is a big question.
Yes.
Please.
We have to go forward with the research, right? And it must be consequence because of the developing of the robot. For instance, reducing the employment, right? And our solution is actually, this is a condition that we cannot avoid. We cannot avoid for the situation. For instance, because of we need to improve the quality of the production, right? And to make efficient production. So robot becomes solution. On the other hand, it will sacrifice the employee, right? And then our solution is you need to I mean to
balance.
Yeah, to balance with the situation, because we can also equip ourselves with new capability, new competency, so we can apply for another job or something. So this is quite difficult for the government, especially because it will reduce the I mean, it will
Passion
produce,
of research.
it will produce the unemployment.
I see. Thank you for the wise response. Yeah. Thank you very much for the question, Mr. Ari Wibowo. And we're coming to somebody else. Well, we're talking about the use of robot to give command. What if the command given by the applicant to a robot is wrong? Then the repeat command over and over again, and the robot experiencing the error and not responding. So what should we do?
Question from Mr. Calvin.
Question from Mr. Calvin.
Yes, since we developed specifically the task of the robot, how the robot will work in the specific domain, right?
Yes.
So we can narrow the opportunity to make mistake by providing the knowledge base. This is actually our solution.
I
So
see.
maybe we can demonstrate a bit of how the robot work, and there are actually still some mistake, but we will improve. Yeah, for instance, how to capture the voice from the applicant. For instance, I will share the hopefully. I don't know. I cannot share anymore. Maybe from my side.
Stuck again?
No. Okay. Can.
Yeah, it's okay.
This way. Because I borrow the laptop from my wife. My laptop is Apple, cannot use the visual background. I don't know. Maybe quite old Apple. Maybe yeah.
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 Well.
Okay.
Okay. At least, what do you think? From your expertise knowledge.
Yes. Pardon?
Okay. Maybe the illustration will be better, but it maybe takes time. Now we're coming to somebody else, Bintang Nuswantoro, Mr. Bintang Nuswantoro, surely from Indonesia. Yeah. Although robotic advances are growing, there are certain skills that humans will do better. Yeah. Is it possible to combine the machines and the humans for the best performance?
In my opinion, it is very possible. It is possible to combine the expertise of human and take advantage of the expertise of the robot developed by the human. For instance, in terms of consistency, right? People less consistent with robot, but in understanding, people can better understand about the task. So we can combine both of the expertise to produce human and computer interaction for better achievement, for better job accomplishment. Something like that.
Okay. Well, okay. Thank you very much. It's also another wise answer. Now, from
the question
from
is
Mr. Wareh Adi Kusuma. Well, we need to be very careful because we're talking about robots, and Mr. Heru, you dress very, very well. Is there a possibility that the robot will not or refuse to carry out the commands given?
Yes,
or is there something to do with the lack of the KR?
Yes, of course. Modeling is part of the is an effort to reduce the error, but still possibility to make a mistake for the one who haven't checked the consistency, for instance. That's why we propose to checking the consistency of the knowledge base after development. and the possibility of extracting rule from the knowledge base become wrong also. For instance, if we produce the new classes and then the class is not related to the current knowledge base, and then the rule extracted from the knowledge base become wrong also. So we'll produce wrong action, wrong task. I think this is very very common actually in the research work before we really share, because we before we really can give to the customer, we have to really focus on the testing and focus on the improvement of the knowledge base.
Okay, thank you very much, Professor Heru. Well, it seems that there is a difference between toys and robots. Yeah, toys usually are for children, and robots are made especially for a special purpose. There is a question from Aditya, Mr. Aditya Tristianto. Do you think that robots are the solution to the needs of the old people?
Yes, I think so.
How about the younger people?
Young people more open to the game. Yeah. Last night we have quite intense discussion with my wife. Actually, my wife is from nursing department, and her research focus is caring elder people, and the need for a robot companion is quite a lot. For instance, the robot can give message to the elder people when to take medication, right?
I see.
When to pray, and then maybe a companion robot can give some advices, or maybe can share the story, and then become a close friend to elder people. I think this is quite interesting. Maybe it will be next project to us.
Okay.
Okay, and well, from your humble presentation, I think maybe you will develop some kind of robot which is cooperative to human being, especially for nurses, right? Not robot which distract the humanity. I think very good, Professor Heru Agus. Well, there is another question here from Mr. Safiq Muhammad. Do you believe that people are able to use robots well? We know that people in this country, maybe in some country, not only Indonesia, often perform actions, vandalism, whatever, often cause damage to the public facilities provided by the government. What do you think? If robots are everywhere in our country and then vandalism is also everywhere in the country, well, the public facilities will be easily damaged. What do you think?
Yeah, actually, this is not a technical aspect of the robot actually. So we have difficulty.
That's why this is all the fear. This is all the fear, sir.
We have difficulty to answer that such question.
Yes.
We cannot easily answer the question because we have to stand for many aspects, especially for the government rule, to help us to keep the services available and work. I think we need government, we need regulation, and also the behavior improvement of the society, I think.
Okay, well, thank you very much. Thank you very much, Dr. Heru. Well, only that in the beginning, we are talking about the robots will have two impacts, positive and negative. That's we are talking about it, and I think that we need to be thinking about it very wisely in the future. But we need to keep the passion of the researchers grow up, right? And just what you said in the beginning. Well, I think we are running out of time, Dr. Heru Agus Santosa. So, well, it is easier to say hello than to say goodbye, but you've been, what is it, presenting something updated, something robotic, and something of, I think, highly interesting for the humanity. Yeah. Thank you very much. Well, ladies and gentlemen, the audience, please give a big hand to Dr. Heru Agus Santosa.
Sorry, waiting for so long time is quite tiring. Maybe some of thing in my head already gone. Still,
next time you're in the force, hopefully. Thank you very much.
Yes.
Thank you very much. Maybe you have some concluding statement for the audience.
Okay, thank you. Actually, what we are present today is still in the very beginning of our study. That's why we are still focused on modeling of the robot. So we need to really focus on this part, because this is become the foundation of the whole robot dimension, and also will produce solid robot, become solid robot research. I think it's enough for my side.
Thank you very much. Thank you very much. Okay. Thank you very much. Okay. Bye bye. See you again next time.
Yeah, thank you.
Dr. Heru. Yeah.
Thank you so much. Hopefully, I can explain well.
Well, it's been quite a long, what a long day. What a long day. I believe that you are staying to the end of this program. Before we are saying goodbye, I'd like to say something. These four topics are interesting. Hopefully, you've been enriched with these knowledges and also the skills presented by the experts from the world. Well, ladies and gentlemen, it is so sad that we have come to the end of this plenary session. We have willy-nilly to say goodbye. We thank you very much that you are still staying to the end of this meeting. We hope that you have enjoyed your virtual time with us and that you have learned something today, or probably lots of things. Titin.
As Prof. Shimanto said earlier, it is easier to say hello than to say goodbye. But sadly, we have to part and say goodbye now.
On behalf of the committee, we would like to submit our apology for everything that we have done wrong or any shortcomings during the virtual plenary meeting today. Titin.
Okay, please stay safe and sound, and we hope to see you again in the 2022, maybe, on Isemantic, to come at our university, the University.
Well, I have something last to say. East or west, home is rest. Isemantic is best, don't leave us. Gadis cantik suka merayu, Isemantic selalu kurindu. Goodbye, everybody. See you next year. Wassalamualaikum warahmatullahi wabarakatuh.
Okay. Goodbye. Would you like to bring it back to the MC?
Yeah.
Okay, ladies and gentlemen, before we close with the seminar, we would like to announce an information regarding the parallel session. Reminder for all authors that the parallel session will be held 2 times. The first parallel session will be held at September 18 at 1 p.m. and the second parallel session will be held at September 19 at 9 p.m. Honorable ladies and gentlemen, it has been a great moment and experience to be a part of this international seminar. Our deepest gratitude to Allah Subhanahu wa Ta'ala and also to all the keynote speakers for mind-sparking discussion, to all the guests, moderators, and all authors and participants of Isemantic 2021. Our sincere apologies for all the inconvenience and thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.